These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Hello, everybody. I'm Sam van Houten. I'm speaking live here from Belgium. In order to, let's say, get to know you, when you're presenting live, normally you can say by the raise of hands, please indicate what your experience is. So I would ask you to fill out a one-question survey at slido.com with 180,880 code, and then we can see so that I can understand a little bit on what you guys are familiar with. So for those who don't know me, I'm Sam van Houten, and I actually work as CTO at Codit, and we are based in Belgium. So we are headquartered in Belgium and actually have 8 offices around Western Europe. We are with 200 people almost, and what we focus on is really on building data-driven cloud solutions using Microsoft-only technologies. Okay. Obviously, I think it's important for everyone to understand that these events are made possible not just by the community and the volunteers that work for this, but of course also by these sponsors. So thanks to them. And then, of course, this would be the agenda. So the agenda, a very short, let's say, explanation of some concepts that I think are important for the rest of the session, even if you don't have the real machine learning experience. The biggest part of the session will obviously be spent on Azure machine learning. And then, of course, I will show how we typically see, let's say, the way from experimenting all the way up to model deployment and actual consuming of models. And I will end with, let's say, the ML ops approach, where you have what's called the CI/CD approach for machine learning. Yeah? So that's the session. You can expect a lot of demos and demonstrations, more than you will see slides. But still, the slides can be shared, and some of the slides I will quickly go through, but they are nice for, let's say, reference afterwards. Also, all the code that I will show is used or published on my GitHub repo. So the link will also be included in the presentation. Okay. Now let's see if people have been filling out the thing. So don't hesitate to indicate what your experience is. And otherwise, let's say we'll not wait and we might be able to come back on this one. A different approach we see with machine learning compared to traditional programming. So with traditional programming, and that's where I started my career as well, you start with data that you get and you write a program. And typically that is executed so that you can get the results. That's traditional programming, and if you execute that program over and over again on the same data, normally the results will always be 100% the same. With machine learning, it's different, obviously, especially if you think about supervised learning. Then you actually get data, and you know that this set of data should be, for example, this result. Think about classifications where you say, these images, they are cats, these images are dogs, right? And what you actually do, you use the computation to take the data and the results and to build or generate the program. And that's different. Actually, the program is what the machine learning contains. And that's a program you will execute. And one thing that you have to learn when you start doing ML is that you don't, typically you're not always 100% accurate, because if you would be 100% accurate, you probably don't even need machine learning. So that's an important thing to take with you. Specific to Azure machine learning, these are the, let's say, the services you can find on the Microsoft Azure platform around AI and machine learning. So if you start at the bottom, there you can, of course, say that there's infrastructure available to do machine learning training and so on. So think about, obviously, the CPU, which are the common commodity processors are available, but some of the things, especially if you start thinking about deep learning with a lot of multidimensional arrays and so on, GPU definitely, let's say, boosts the performance of your training. So GPU infrastructure is available as well. Then you have the FPGA that is, of course, also available, for example, with the Edge hardware that Microsoft offers. You have different services. So I will focus on the Azure machine learning service here, but you also have the Databricks and, let's say, pure machine learning VMs. So that's an important one to take. And then, of course, I hope if you've been following Microsoft for the past, I think, 8 years or something, that they really have embraced the open source and community frameworks, because that's also what the direction has been by the community. So they embrace all these popular frameworks. Think about PyTorch, Keras, TensorFlow, and sklearn, and ONNX. And obviously, if you would, for your specific case, require a different framework, you can always add it to it. So there's no restriction really there. And then you have the data science tooling. So if you're familiar with Visual Studio Code for your coding for Python scripts, you can obviously use that for your data science. But if you want, you can also use Azure Notebooks in the cloud, where you have an environment where you can just create your notebooks and execute them on, let's say, the compute in the cloud as well. Obviously, and that's what you will see in the demo, Jupyter notebooks are supported as well. And what I also want to do a short shout out is, let's say, the entire combination of services that they offer around cognitive services. And so you have cognitive services for vision, speech, language, and so on. And to be honest, for a lot of, how would I say, common scenarios, imagine that you build a solution with a website and you want to have people giving feedback or even uploading images of certain things. A common request is, for example, I want to make sure that I get notified if someone has a very bad review of something. Or maybe you want to avoid that people use swear words or offensive language. Maybe if you do pictures, you want to make sure that there's no violence or even nudity in the pictures. You can obviously start training your own models for that, but to be honest, that problem is so common that it might be much easier to just use these cognitive services for those commodity problems and have that being called on an API. And let's say in a matter of a few, say, hours, you can include that. So what I will focus on in this session is more on, if you have your specific machine learning model that you have to train, then this is the way that we use machine learning in order to make it enterprise ready. All right? If you have questions, I assume you can just enter them in the Restream window. If you then, from the entire Azure machine learning offering, zoom into machine learning itself, then you can indeed see what they offer. So, as I said, they offer compute. And the nice thing is you can have the compute, of course, in the cloud, but you can also execute models that you've been training. For example, you can execute them on the edge. And what we do is performing a lot of IoT projects. And quite a lot of times you want to have the AI or the machine learning models for predictive or specific fault detection. You want to have them running as close as possible to the hardware. Because, for example, one of our customers has vessels on the ocean, and they don't always have internet connection. So you don't want to rely on an internet connection in order to, let's say, validate stuff. The nice thing is that we train the models in the cloud and we execute them on the edge. And if there's a new model, let's say, ready, then we can push it to the edge. And if the connection at that time is not there, the model will be pushed to the edge as soon as, let's say, the connection is being made. So it's like an asynchronous store and forward principle for that. So that's on compute. You can obviously have a lot of orchestration with pipelines and the designer. But I would say the main concepts are around the data sets that you can manage, monitor. As you can see, data sets for data drift and things like that. You can train your models with experiments and runs, and that's, I think, where we will spend most of the time in this talk. And then you can register your models in a registry. You can serve them through batch or real-time endpoints, and that's also something that we will show. And on top of that, much like any other service in the Microsoft Azure landscape, you can automate everything. So you can everything you can do is with the SDK available from Python or C#. They have HTTP REST points. You have the CLI to do things. So that's important because that is something that will be used by the MLOps approach that I will show at the end of this presentation. And then, of course, you have the experience that I already mentioned. So that's the offering of machine learning. What it actually is that behind an Azure machine learning namespace or workspace, there's a lot of things, let's say, services from the Azure platform. So you will see that if you use Azure Machine Learning, that behind the scenes, you will have a container registry because they create a lot of images for you. If you host a model, then they can create a container instance, for example. If you serve, or if you have your experiments and you track your instances and your log files, you will see that all of that is actually exposed and available through an Azure Blob container. So it's really that machine learning adds things on top of compute, storage, and container things. Now, in order to get quickly started, I just want to get a rough walkthrough of what Azure Machine Learning offers and take out two different things. The first thing I want to take out is the AutoML part, and the second one would be the designer. Right? So for that, let's go to the Azure portal. And that should be here. So this is the Azure portal that I assume most of you are familiar with. And what you can then do from, let's say this is inside a resource group, I have a machine learning workspace. And this is inside the Azure portal. If you then want to say, dive in the details, you actually say, I want to launch the studio. And it opens as a ml.azure.com thing. So it's outside of the portal that you get navigated to. And from there you can get started. So this is where your data people can get access to without really requiring to log in through the Azure portal, because most of the times you don't want to have your data engineers being able to mess up things in your Azure subscription. And what do we find? You have assets and you have the manage. So you will see that we have compute, for example. You have compute, different compute things. So here we have the compute cluster. And this is, for example, a GPU training cluster that I have made. And if I just click on that one, and I hope the internet connection is good enough because it seems to be quite slow at this stage. But if I click, you can see that I have a cluster node of one node. And you can see that this has the different properties here. So the node at this stage is idle. And what I can easily do, I can start scaling and changing the properties of my my actual node. So I can say, for example, I want to have a minimum of 2 nodes. And as soon as I do that, you will see that my state here becomes something that that is resizing. So I'm resizing from 1 to 2 nodes in this stage. Okay, so that's the way you can define your cluster. Actually, what you will see in production is that you will scale from 0 to a maximum nodes. But I just want to provision some nodes here so that we don't have to wait as soon as I launch some experiments. Okay? But the nice thing is it scales down to 0, and you can scale up to a maximum of a number of nodes depending on your environment. Then you have, let's say, the data store and so on. But I think if you then dive in the data sets, that you get some nice insights, for example. So you can register different data sets. For example, here I have one from my time series demo, where you can see this is the engine data. So this is data from, I think, measurements of 100 engines. And if I then just say, okay, let's explore, you can perfectly get a nice overview and an understanding of how the data set looks like. So this is just a sample of the first 50 rows. But if you then click on a profile, you actually see how the data is distributed for every property. You can perfectly see the averages and the amounts. You can see where do I have missing values and so on. This is already quite helpful to do that. What you can also do is then start monitoring these data sets for data drift and changes. Okay, so that's an interesting one. And if you then want to consume it, yeah, you just copy paste if you want the different, let's say, code pieces. And that's an example here where you can perfectly understand how you can use the Python SDK for Azure Machine Learning. Okay, so just by executing this, you can, for example, say, I do a data set, I reference it by name, this is the name of my thing, and then I say to pandas data frame, and if you're familiar with Python, you will definitely know how the pandas data frame looks like, and then you can start working with that. As I said before, so I will talk about experiments, the models, and so on in the next demo. There were two things that I wanted to take out. One was the designer. I have to be honest, the designer is not something that I use too much, but it helps in, let's say, visualizing the things. But I see most of the data scientists that work in our company, they really work with just plain notebooks and Python scripts. But for example, you have some standard things available here, like I want to predict the automobile price. And then what you can see is that, yeah, you have a lot of assets here, 97, that you can drag and drop. So there's, if you want to say, okay, I want to use a specific regression model, you can say, okay, let's drag and drop it. And you can, let's say, you can use this for cleaning, for scaling your data, for doing a lot of things. So it's very visual. But you can definitely also just insert scripts into these things. So there should be something that is called Python script, and you can just drag and drop it, and then you can see here what you can just execute, right? So this is something that makes things, at least is an approach to make things a little bit more easy to do, and you have a nice flow that actually builds a machine learning pipeline if you want. The next thing I want to show is the automated ML. Automated ML, and actually I have to switch to another namespace here. Just a minute. Yep. So this is another workspace where I had this setup. So there I have the ability to run an automated ML. So what does that mean? You don't have to know too much about machine learning. You don't have to create your own scripts. What actually you can say is, I want to create a new automated run, so automated AutoML. And in this case, I will use the Kotakol one. What is Kotakol? This is a very short, let's say, demo. But this is an app that I have built. So Kotakol is actually 1,000 climbs for cycling, so 1,000 hills inside Belgium. That actually get a score. So this is like, you could say, the higher the score, the tougher, the more complex the climb is to do with your bike. And that's based on the length, the elevation, so how much meters in height do you have, and of course the steepness of the climb. Okay? So these things are taken into a data set, and that's what you can see here. I will take that data set. If you want, I can click on it, and I get the overview with these things. So you can perfectly see that this climb, for example, has 11.5 and so on. You can, just like I've shown, see the statistics, where you can perfectly see that, most of the climbs seem to be, let's say, shorter in distance and so on. So what I will try to do, I say, okay, I want to have Azure Machine Learning trying to experiment and find a model for me. I will give it a new name that is called Sophia AutoML. And then it says, based on the Kotakol dataset, which column, which feature do you want to predict? And that's, of course, for me, the points. So the points is the actual feature that I want to predict. And then you can say, okay, let's take a specific cluster. Let's take this one. And you can click next. And then you can specify automatically, because it sees that the points, or let's say numeric values that are, let's say, not really classes, it automatically proposes that this is probably a regression that you want to do, and that's right. I'm not predicting, to have 2 or 3 classes or something, but you can see that if you want to do classification or time series, that's possible as well. What you can also do is you can say which is my metric, and for regression, this is a common one, so the root mean squared error. And you can say, if you have an AutoML model created, you need to explain it so that I can indeed understand what is behind the scenes. You can also say, for example, you don't want to have random forests, or you don't want to have the elastic net, so you can exclude some specific algorithms. You can also say that you want to stop the training at a specific time, and let's say the minimum training amount is 30 minutes. So you have to assign at least 30 minutes, but you can say as soon as you have reached the training job of 30 minutes, you stop. But you can also say, I'm happy with, imagine that you would have an accuracy for classification as a metric. You could say, I'm happy if you have the metric accuracy of 90 or above. And that's something that you can perfectly set. This is the RMSE, so this is a little bit tougher. So let's say maybe if you want to have a 5, that's good enough. And by doing that, you can say finish, and then the AutoML script would run. As you can see, it would run at least 30 minutes. So what I do here, I go to the experiment that I executed in April. And there you can see I did a run here. The run took indeed 28 minutes. And if I click on it, you can see that behind the scenes, I have a lot of, let's say, 81 runs that it did. Runs can typically take around 1 minute because it's not a big data set, it's 1,000 flat file records. But then you can see, okay, these are the models that were used. And what you can perfectly see, if you go to the runs, you can say, no. You can say this is the best model summary. So this was the model that, and that's quite common, an ensemble. So where they have the root mean squared error of less than 0.08. And if I click on it, then you can see this is the model that I can use. I can even start to deploy the model. I can download it as a specific file that I can import in my own code. And what is nice as well, because I said the model has to be explained, I can say, okay, let's have a look at the explanations. And if I click there, for example, what I like is to see which features of my data set have the biggest impact, to the Kotakol points, for example. And if I add, let's say, maximum of 5 features, you can see that the higher the climb, so the more meters you do in the climb, the tougher the climb typically is. And that makes sense. Also, the longer the climb makes sense. So the number of degrees, the steepness, has less impact. And then obviously the surface, if you ride on cobbles and so on, does not have a big impact on the outcome. So this makes you understand several things already. And then you have, of course, metrics that you can see, so which values are there. The R2 score is a common one that you want to see and things like that as well. Okay? So this is AutoML, and that was the, let's say, overview of Azure Machine Learning to get started. Now, what we typically do, if you want to do real experiments, is to say, okay, you want to start locally. So, and to demonstrate everything, I want to use the MNIST dataset. So if you have experience, if you have been following trainings, courses, demonstrations, chances are quite high that you have seen this dataset already. So this is a dataset of 60,000 images, images of handwritten digits. They are just stored in a 28 square pixel file. So that I think is around 700 and something array values that you have. And this is a common classification program. So what you want to do is train a model. You give it a digit, and the model should say this is one of the 10 classes. It's from 0 to 9. As I said, this is probably the hello world of machine learning. So my session is definitely not about how to do a specific machine learning. This is more how to leverage Azure Machine Learning for this straightforward hello world scenario. Okay. One thing that I always, in every AI or machine learning presentation include is the concept of the confusion matrix. I think this is one of the most important things to understand, even if you are not the machine learning expert yourself. I think if you work with people that build models, that you don't have to understand everything they do, but you have to understand how to evaluate the, for example, classifier they have. And so I want to know if they come up with, oh, we have 87% of accuracy. I want to know what that means. And I also want to know, yeah, but what the 13 that you have incorrect percent, which ones are they? And that's an important one with this confusion matrix. So the easy ones are, of course, the ones that you get right. And that's typically from the top left to the bottom right. That should be, let's say, always the highest numbers. And that means if you have predicted the value to be positive, to be a true, and it actually was a true value, then that's a true positive. The true negative is I predicted it to be of class negative, and it actually was negative. So I'm doing here with the binary classifier, but if you have multiple classes, like in the MNIST, you would have 10 different classes in columns and 10 rows. And then you could say I predicted an 8, and the actual was an 8, so that would be on your diagonal, and that would be a true value. Now, the false negatives and the false positives, that's an important one, because they can have a big impact, and maybe you need to tune a model to avoid one of these. Maybe it's not as bad to have a false positive, but having false negatives might be much worse. And maybe it's okay if from the 13% that the model did not have correct, that if most of the percentages are in the false positive, you could say, oh, for me, that's fine for my specific business case. So if you then take the example of COVID or cancer, and you have an image of a lung, for example, or of, whatever, an X-ray, and you just want to have a model trained, then you could say, okay, if I now have an image that actually I predicted to be negative, so that means this person does not have COVID, but the actual was that the person has COVID, I think in that specific case, that's much worse than having a false positive. Because if I would say that the model says, I think this person has COVID, but it actually does not have COVID, it's not as bad, because typically if you would have, let's say, the person taken out, you would do a follow-up, and you could say, oh, you don't have COVID or you don't have cancer, it's still fine. The first one, the false negative, in this case, might be definitely worse, because the false negative could mean the model says this person is okay and healthy, so you can go out. You don't have to see a doctor, and that would be a tricky one. So in that case, I think I want to make sure that I avoid the false negatives much more than the false positives. And maybe for an alarm, imagine that you have a smart camera at home. For an alarm, it could be the opposite. Maybe you say the false positives you really want to avoid, because if you have constantly a notification to say, hey, probably someone is breaking into your house, and it's just a cat of the neighbors that passes by, then having too much false positives would not be a good thing. So that's what I mean. It's very important to have that, and you will see this coming back, the confusion matrix, in all the experiments that I do with the Azure Machine Learning for classifiers. So some other things more for your reference is, of course, accuracy is a very common one that just says how much percentages of your predictions were correct. And then you have some other things that I definitely won't dive into details, but you can take this as a reference. Now, one thing I want to do a shout out as well. So we support and do a lot of things for free for the community and open source. So if you see samples for Azure Machine Learning included in your notebooks, one thing that you will find is that your, let's say, experiment notebooks would contain way too much calls and code to Azure Machine Learning. You actually want to make sure that the developers and the data scientists in your team don't have to bother too much about Azure Machine Learning. They can just focus on the actual data problem at hand. And for that, we have done this. So you can just install the package of Arcus. So Arcus is our open source thing for Azure. So if you want to have logging, eventing, and all these things for .NET as well, just go to arcus.net, azurearcus.net, and you can just take everything you want. We did one specific for Azure Machine Learning. So that's the one that you will see that I use. But behind the scenes, if I click here, for example, behind the scenes, if I just go to the code on GitHub, let's go, it's here, Arcus, Azure ML experimentation, for example. Then I can say, for example, to say something like evaluate classifier. So in the demo, I will execute and call this method, evaluate classifier, I give my model and so on. And behind the scenes, what we are doing, we actually say, I create a metrics report and so on and so on, and we will add these things into the Azure workspace. So the complete run, for example, is a call to the Python SDK of Azure Machine Learning. And that definitely let's say, wraps a lot of code into the common things. So just a shout out, free for you to use and to contribute if you're interested. So the approach that we take, if we have a data set and we need to do experimentation, is most of the time that we say we still experiment locally. We want to start locally because too often you have, let's say, syntax that is incorrect. You want to see which parameters you use. Maybe you already want to use some different algorithms that you think might give better or worse results. So you experiment locally, typically on smaller data sets. So I think we all know that the bigger the data set, the more accurate your machine learning can be. So if you have smaller data sets locally, then your runs will be faster and so on. So experimenting locally is really focusing on the syntax and the feasibility, getting decent insights. But the nice thing is you just do shift enter, and after a few seconds you get results. So your training cycles are quite small. However, for these local experiments, we still want to track them to Azure ML, and that's what you will see in my next demo. Once you're happy with, let's say, the syntax, once you feel that this is probably the model that I now really want to train on the big data set, and I want to do hyperparameter tuning, then you say, okay, let's take now the code snippets from my Jupyter notebook, for example, and copy them into a script. And then you say, I will now take this script with the prerequisites, so the required packages, and that's something that I will schedule in the cloud. And what we do is we make sure that the script has a lot of arguments that you can pass if you experiment in the cloud. So arguments such as the hyperparameters. If you say we have a C value that we want to try, then you don't hard code it in the script. No, you actually say, let's pass the C value as a script argument, and then you can, for example, train 5 different scripts, 5 times the same script with a different parameter, and that's let's say a parallel run in the cloud. So you have multiple runs in parallel, and then they are defined by your Azure ML cluster that you have set. So you saw me now set up the cluster between 2 and 5 nodes. So if I have 7 runs that I schedule at the same time, it will scale out to 5 nodes. Each one of the nodes has one script that it runs. If one of the nodes is finished, it will take the next one from the queue. So the 6th one, and the next node will be the 7th one. And then the other node that looks at the queue will see there's no job anymore, and it will wait the timeout and then, let's say, scale down. That's the way that scheduling typically happens. And as I said, everything behind the scenes on compute is Docker-based. So what you will see is that if you have a new script or new required packages that you pass, then actually behind the scenes there's a different or a new Docker image that gets created. So you have to understand, if you change your script itself, it typically takes longer to run and schedule in the cloud because it has to build a new container image in the container registry and then schedule it. If you just say, I execute the same script, but I use different arguments, then it's immediately, it takes the same image, and the arguments are, if on a Docker level, seen as environment variables. Okay, so that's the approach. Start locally, small data sets, quick feedback. Once you're happy with, let's say, syntax, then you want to make sure that you have better results on the bigger data set, and that's where you use the cloud compute for. But everything will be tracked in Azure ML. That's the principle of experimenting that we follow. So to summarize that in a more visual way, you will see that you start from the data set. I have in my Azure Machine Learning, I have the MNIST data set. And then you create an experiment. And in the experiment, you will have multiple runs. So a run could be a different script that you schedule. It could be different parameters that you try with the script, and so on. So you can have multiple runs inside one experiment. That's the container, the boxed thing that you have there. And then if you have done the different runs, you can say, oh, let's pick the best run. And for you, the best run could be that maybe you say the run with the highest accuracy. Maybe it's the run with the better F1 score. So again, depending on metrics and so on, just select the model that from your, or the run that from your point of view has the best outcome for your business case. And if you then take that thing, you can say, I will now register that specific run The output of that model I want to register in the model registry. So here in this case, I already have from another experiment a model B available, and you can see you can have multiple versions. So if you then say, okay, let's take that specific run, you can say I now register the fitted model of that run. I will register it in my model registry as model A, version 1. Behind the scenes, what actually happens is that in every run, you can say, I will now save the compiled model. It could be a pickle, could be ONNX, and so on. But I will save that specific model to the output folder of my Docker container, and that is actually being copied to an Azure Blob Storage. And if I then say I now register the model of that specific run, actually you add just a link to that blob storage in the model registry. So at this stage, you cannot call the model. It's not hosted or served somewhere. It's just registered, and you can refer to it through the SDK and so on, or in the portal you can see this is the model, and it was linked with that run. The next step, if you then say, now I want to serve the model, or I want to have an endpoint, an API if you want, that actually takes one or more models, that's what you can use endpoints for. So you have an API endpoint that could be hosted on compute. Think about ACI, which is Azure Container Instance. Think about AKS, which is the Kubernetes cluster on Azure. Or you can even host it on the real-time serving endpoint that is now made available. So in this case, I could say I reference the first version of Model A and the third version of Model B, and I will serve it as an API and call it from there. That's, again, the high-level overview and the principle that we have here at work. So let's now show how that thing, let's say, behaves, how we typically execute that. And we will show that in a demo, of course. People that are familiar with machine learning will definitely recognize this thing. So this would be my Jupyter notebook, where I have, as you can see, referenced some things. You can see that I have also referenced the Arcus Azure ML package. So the only thing that I have to do, I actually say, let's create the name of a training, and I will do logistic regression for that MNIST dataset, and let's give an experiment name. So I here said, since this is a call in Sofia, although I'm still in Belgium, but let's say that the experiment name will be MLConf Sofia. What you then do, I have a behind the scenes file, config.json, that actually has a reference to my Azure Machine Learning workspace. You can see what I need to have in that file is actually these three things. So you have the name of your workspace, you have the ID of your subscription, and you also have to say in which resource group do they belong. So based on that, you will then be pointed, and you have to enter your credentials, obviously, to get connected to that workspace. So that's what happened here. I now have a reference to my Azure Machine Learning workspace, and I can start doing stuff. The first thing I do here, and the scrolling goes a little bit wacko. The first thing I do is I want to load a tabular data set. So if we go back here, it seems my CPU is going in overdrive, so I hope things will be smooth enough. You can see I have the data set in the cloud. So I can click on it and I can probably see how big it is. I think it's a 70 megabytes or something, 73 megabytes, and it has around these 60,000 records, right? So I can just say, let's connect to that data set, load the data set into memory, and then that would be, if you, if I think I do something like this, aml.df, see that this is a pandas data frame, right? So I have now a data frame that actually is linked or is a copy from the data set in the cloud. So I don't have to bother with files locally. I don't have to save them. They are now just in memory. What I do here is just specifying, I don't want to train on the 60,000 records. Let's just train on 1,000 and take 250 for the test set. Perfectly fine to do that. So that's a little bit of those things. What we then do is, of course, as a demonstration, I just say, what's the 31st image? It's an 8, and this is what an 8 looks like if you plot it, so nothing special. just so that you understand, we have around 700 and so much values, and these values go between 0 and a 255. What does that mean? 0 is a black pixel, a 255 is a white pixel, and everything in between is gray, right? So this would be the let's say the representation of this tree. And then I can also, by using the Arcus one, I can say, okay, just visualize some random classes, which I do here, and I say, okay, take 6 images and see which class they are at. So you can perfectly see that. Nothing special, nothing Azure ML specific until this case. What I then do is use a scaler. You might be familiar with that, but instead of scaling between 0 and 255, we scale between -1 and +1. And then this is where I actually start my my actual training. So what I will do is I say, okay, let's start an experiment. And then I do a logistic regression. So this is the link to Azure ML. This is all executed locally. As I said, I'm executing locally in memory. So I do a Shift Enter. And you can see that this will be executed quite quickly. So in 3 seconds, I get back a model that has been fitted on my smaller data set. What I then do is, let's now evaluate image classifier. So I say, I call that method that you have seen that I showed on the GitHub code. I pass the model, I say, this is my test data sets. Please save 3 failed images for reference. And yes, please don't execute the run and so on, and upload the model and things like that. So I just do a Shift Enter again. And the model that I trained locally has now been evaluated and has been persisted into the cloud, into my experiment. So if I click here, you can see I have an MLConf Sophia with 1 run. So if I click here, that specific run, I can see that this run has been executed. It has an accuracy of 88, which is not that great. You can definitely go much higher. But I can see the metrics as well. And this is what I already said sometime. The confusion matrix for classifications is quite important. So obviously from the top left diagonal to the bottom right, you can always see that the highest values should be there. But for example, you can see that some values get a 2, for example, like here. And you can see if you hover this one, there's 2 predictions where actually the model predicted them to be an 8, but the actual was a 3. And if you visualize a 3 and an 8, you can imagine that they have a lot of things in common. It's like the left is different, but the entire right is the same thing. And you can see that, for example, a 3 and a 5 also have some similarity. And visually, yes, that makes sense. But a 4 and a 2 did not happen, for example. So this is definitely interesting to understand how your model behaves. Again, you can see I trained with this parameter. So even if I trained locally, it's visualized in the cloud. Remember that I said, please save 3 incorrect predictions. So for example, this is a 5. This was predicted as a 5, but actually in my data set, it was classified as a 3. And again, you can imagine that this is not very unlike a 5. Right? So you could have some doubt on these things. So you can see that we have saved some different images, just like this is a 3 or a 2, and a 9 or a 7. Okay? What you also have is actually that we have a snapshot of everything that happened. So I can perfectly see that the time that my training happened, this was the code that I was using. So even if I will be a few months down the line, or maybe this data engineer left the company or is home on holidays, someone else can perfectly understand that the model that we have in production was actually trained and built by this specific code with these specific hyperparameters and arguments. So that's a very important concept to get. Okay. Now, getting back to my notebook, for example, what I do here, I will schedule 3 trainings locally with 3 different C values. So 0.01, a 1, and a 5. So I just execute the same training and I call the evaluate image classifier on the Azure ML. I call it 3 times. So it's a 4 value in 3 things. So going back here, you will see now, hopefully, that we have different runs. They are still running and so on, so they take 12 seconds. But the runs are there, and you can see that the accuracy, for example, with this specific C value is already a little bit higher. It's 89.2. And if we do another run, you can see that the fourth is active as well. Apologies. So again, experimenting locally, but every experiment I did is being tracked in the cloud. So this goes fast. I don't have any compute in the cloud. I actually pay less than a penny for this, because the only thing that happens is this gets linked into an Azure blob storage. That's the only thing that I pay for. But you get so much more back. You get this nice portal with a nice and full history of everything. Now, imagine that I say, okay, I'm quite happy with my code, the code that I have created here. I think this is okay. I'm ready now to schedule a few trainings, but not on my laptop, because I really need to, stop working, or I want to do other works. And let's just schedule trainings in the cloud, multiple in parallel on the big data set, and with different parameters. Then that's the next step. So what we do the exact same thing. And here, for example, we will say start a training, and we pass a training name. And this is the thing that I want to show. We now actually, instead of using the Jupyter Notebook, we use this training file. So this is a train.py file. And so it has the same code as the ones that we did show few, in the notebook. So scaling, making sure that you fit the model. And then at the end we say, okay, let's now save the actual model. Oops. So let's save the model. Here in this case we use a pickle file to the outputs file. So you have to remember one thing: everything you save to the outputs folder will automatically be persisted to your blob storage and will be available for references later, even if your Docker container image is already long gone. So I'm just copying the code into here, and the thing that I have added is I'm actually taking arguments. So I say if you pass in, for example, this, as an argument, then I will store this in this variable. The same thing goes for, do you want to have multi-class, class weight, what's the train test split ratio, common things that you want to play with in your experimentation. For example, here I can use a different solver, and if you don't provide the argument from the training script, we will default to the LB FGS solver. So just, you don't have to bother about what do these actual values mean. Just know that these are a lot of times hyperparameters, or things that will change the way your training happens, and we will pass them from within the script. So what I say here, I pass 3 arguments, the 1.92, the type of solver that we have, and let's say 25% of the data set should be used to test the model against. I do a shift enter, and what happens? We will actually now schedule the training of that specific script, and we will schedule it on the compute target GPU training. And so we will schedule the training in the cloud, and you get back the link. I can now actually close my laptop, go for a run. My training is being scheduled in the cloud, and that will take some time. So what happens? Let's go back, here, to the exact same experiment. We do a refresh. You can see that the previous experiments were running on a compute target local, but now I have a training scheduled on my GPU training. If I click on that one, you can see that it is running, and I can go, for example, to the log files. And what you can see here, if you are familiar with Docker and Docker pull commands, this is the thing that happens now. So it's taking an image that I actually have prepared already, and you don't have to prepare the image. The image is automatically created by Azure Machine Learning, but since I executed with this script in the past, it just pulls the image, and it will start setting up my script. So I can perfectly follow this live here, but at the same time, I go back to my notebook. I can do the thing here. So let's take 1, 2, and here 3, so 6 trainings that we will schedule at the same time. So I'm just scheduling trainings here in the cloud now, and also them will be pulling the Docker container from the registry, and they will start scheduling the trainings. So if I click here, I do a refresh, you can see that I have different trainings that are getting queued because my GPU cluster only had 2 nodes active at this stage. So some of them are being prepared and some of them are being run. You can even see that the first one that we had is already in the finalization stage. So if you click on that one again, you can see this is the actual output of the logging that I had. And the nice thing is, if I click on the metrics, again, you can see my confusion matrix, but you now see that it has much more values because I trained on a larger data set, and you can see they have around 1,000 correct values for every digit. And again, for example, 39 confusions between 5 and a 3. Right? So that's a nice thing. Imagine then that you have all these trainings scheduled in the cloud. You still want to have a good overview of, okay, which one has the best accuracy. So you can add that to the columns here, and then you pick that model to be further used. But you can imagine that you go back here, you can still perfectly see these were the items that were used. So I was using this solver, this was the C value, hyperparameter, and so on. What was the script again? No problem, go to the snapshot, and you can perfectly see that this was the actual script of my training. So again, it's an end-to-end reference and a link between everything that you have here. So all of that happens. The next thing that you have, if your models and your trainings are ready, is actually that from one of these runs, you say, this is the model that I now actually want to start serving. So if you go back again to here, and by the way, one thing that I probably did not show yet, if I click on the GPU training, you can see that it's now resizing from 2 to 5 nodes. So 2 of them are active, but it's now scaling out to more compute instances of this size. Once, you can see they are here now. So 1 is idle, 4 are running. So all my jobs are now in parallel. Once they are ready, they will scale back down to, remember, I had a 2 here. Now, if I click here, for example, on the run that was finished, it has an accuracy of less than 92. You can then say, okay, let's now make sure that from this run 7, we will take that one and we will deploy the model. So doing that is done in this code. So this is just the Azure SDK for machine learning, where I say deploy the model of run 6. So if I do Shift Enter, oops, somewhere there should be a typo. Model name is not defined. I had to execute this one so that the variable was set. So I'm saying deploy the output. Remember that in my script, I stored it into the outputs file as a pickles file. So deploy that model of run number 6 into the registry. So if I go now here, and I now click on models, what you will see is I have a new MNIST version deployed. And you can see it from the experiment mconf Sophia. So this is the new model version. And again, if later on, few months down the line, someone says, we need to update the model, something has to change to the model, I don't like the model anymore, you can perfectly still click on the run. You can see which arguments, what was the script, even if people forgot to git commit and things like that. Okay, so going back to the model, the only thing that I now did was register the model as a new version, and I could add some tags, like this is the output of number, and I have an input of array and things like that. As I said, the model has now been registered, nothing has been deployed. So if I execute a few of these extra things, and what happens is that you can actually say, I will set up a new web service, and let's say it's a V2, and you do Shift Enter. So I will not explain all the code, but what happens is actually I will now start serving and creating an endpoint that takes this file here, the score.py. The score.py file is the file that actually will be executed if someone calls that API. So I will not wait for that to finish, because what I actually already did, you can see the V2 is being provisioned, but I already have a V1 of a previous run that is active. So you can see it's deployed on a container instance, and you can call it. So this has a public endpoint, a REST endpoint that you can call. And if you want to consume it, you have to pass in a key. So the key is here, authentication key. And if I then, for example, this is Postman, so I call this scoring endpoint with 2 digits. If I click a send, I get back. This is probably the first one is a 7, and the second one is an 8. So that's the way you can start serving all these models. So in order to train a model, you have a train.py and you have a score.py. I will not dive into details, but they are available if you click through on the example code or in the GitHub one. Now to finish, a very short overview on what actual ML Ops is if you combine it with Azure ML. Well, actually, it's nothing more than making sure that if you start the experimentation, that you will still do interactively, that all the rest can happen automatically. So that you say, okay, as soon as I now have defined my best model, let's now check in the code, check in the hyperparameter script and so on. And as soon as that gets checked in, let's automatically deploy it into the model registry. From there, set up a compute instance. And what's very important, if you start predicting it in production, if you can get model telemetry, so an example, if you have to predict the queuing time at the airport, let's say the queuing time for tomorrow, then I would say if you predict it today and make sure that tomorrow the actual queuing time is also being measured, so that you compare the results, that you can perfectly see, yes, my model is predicting well, or I see that my model starts to drift and is getting worse and worse applications. And that's the analyze that you do. So if you analyze that your model is getting let's say not as good as it should be, then you can say, let's retrain the model, let's retrain on the updated data set and have the entire sync again. So you don't want to start, let's say, deploying models from your Jupyter notebooks into production and so on. You really need to make sure that it's, let's say, typically around Git automated. So this is the thing, the workflow for that. So you collaborate with code, you check in everything, you train the model in the cloud, you validate your model, and then you say, okay, let's now deploy it and start monitoring it, and that could trigger a retraining. Now, in order to do so, and I will not dive in those details today, but just give it more as a reference, you can use Azure DevOps. So if you're familiar with Azure DevOps, that's, let's say, the GitHub Actions, for example, or the GitHub thing of Microsoft Azure as well. And there you have the machine learning application that you can install to build a model, train a model, and create the pipeline artifact. And then you can deploy the model. So that was the CI, continuous integration. Continuous deployment is you can pick one or more of the compute deployments, and you can say, I will now deploy to ACI, AKS, or an app service. So a quick demonstration of how that would look like is here normally. If I click on the pipelines, I have normally 2 pipelines, the CI and the CD, if you remember. So if I click on the CI pipeline, you can see an execution of one that happened. So you do some tests here, where you get some insights in. Oops, let's go back. So you do some tests, you do the actual training of your model, and you evaluate everything. So you can see I have triggered the ML training, I invoked the pipeline, and let's now publish the actual model that was trained. The next thing that you can then do is actually deploy the model into a scoring endpoint. And that's what you see in the CD pipeline, so the deployment pipeline. And if I click there, then you can see I had 3 stages because the other ones were disabled. But one of these stages is deploying to ACI. But you can also deploy to a Kubernetes cluster or to a web application. And all of that is just by, if I click edit pipeline, just by installing the Azure ML, let's say, components into your Azure DevOps environment. So this is the pipeline that you get. Also in the in the GitHub repo, you will find all the source code for those things. So let's not wait for that. Here you have it. So you can perfectly see I'm, for example, deploying here to CI, ACI, and things like that. All right. Now, we're getting close to the end of the session. Before I finish, I'd like to, let's say, give some nice takeaways. I think the first takeaways are definitely these 3 URLs that you can go to, because there you get all the code. You can use everything for your own benefit. I think the takeaway that I have is every experiment you do, make sure that you can track it. It does not cost a lot of effort, but it can be so much more valuable over time. We've all been in situations, if you work with machine learning, where you start experimenting, you have quite okay results. You still want to get the results better, but actually you start playing and changing things, and the results get worse, and you forgot how to get back to your better scoring training. So for that, I would say store everything in the cloud with, let's say, 3 lines of code. You can do it. It does not come with any cost. The cost only starts if you start to use compute in the cloud. Huh? So that's what I say. Treat your machine learning models like they are code. Make sure that they are checked in. Make sure that all the deployment and versioning happens automatically. And that is what you get with the ML Ops approach. With that, if there's questions, I will see them showing up in the chat. But I would say thank you. Let's connect. So you can find me on GitHub and on Twitter with my first name, last name, Sam van Houten. And other than that, I would say don't hesitate to contact me online. Thank you, and enjoy the rest of the conference.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings, as well as a personal budget of 1,024 BGN, and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
Start my days, sun rays, I tap the phone, coffee's on, I mow the lawn, impressing Sean, so connected, so effective, I let it drop, clean it up, heat and smart, I do my part, get in the car, superstar, they're watching me, IoT, IoT, IoT. IoT, I check my stock, what a shock, buy some prawn, my oven's on, coming home, future zone, all for me, IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, makes every aspect are effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Hi, I'm Timothy Span. I'm a Principal Data Flow Field Engineer at Cloudera. I'm based in the United States, so unfortunately I don't get to join you in Bulgaria. Hopefully you have great weather there. It would be really fun to see you there. Hopefully you're enjoying all the talks. My talk is using the flank stack for Edge AI. And one thing that you'll find unique is this is all open source. So no matter where you work, you could download this on your own home laptop and build your own applications. You're not stuck using a specific cloud or some paid software. I've got links to my GitHub, my blog, and my meetup. I do some events in person here in the United States, but they are all streaming live and they all go to YouTube later. So if the time doesn't make sense for you, please just log in. You can watch the YouTube videos at any time. If you have any questions, you can put comments there or just leave me a note on any of the places that you see. And I'd be very happy to talk with you about different things within streaming software, IoT, Edge AI, lots of different topics. Again, some more ways to get in touch with me if you'd like me to join you at another event or just want to go through some difficult problems that you might be having in open source. Just reach out to me and we can do something together. Again, I mentioned that meetup. Try to run it like once a month, sometimes more. If you'd like to be a guest speaker, again, reach out. So I'm doing a lot today because we've got a full. I wish I was there live so we could do Q&A, but I'll just go through this. If you need to reach out to me, hopefully I'll be in the chat. Otherwise, leave comments there and I will reply to you. Or I can put that in a GitHub and you'll see that later. So who, what, where, why, what's the use case? What are we doing? What tools am I using? And, how can you get them? How can you start using them? How do we add deep learning in there? Again, part of that Edge AI. We're talking Edge, so device agents. Where are they running, what kind of hardware, what options you have there, and what's the overall architecture, how do we get this done, what's some of this data look like, what does the hardware look like, and then a fun thing on continuous SQL, which you might not have heard of before, but this is real-time event streaming SQL. So I run a SQL query and it's always running, waiting for new data to arrive. So I get an event in, that goes through the SQL and your SQL runs as if it was a table stored somewhere. We'll walk through a pretty extensive demo. All of that is open source and I link to the GitHub so you could download it and start doing your own applications based on this. So use pieces that you like. We'll give you some takeaways. We'll talk about other events that are coming up hosted by my awesome friends in Bulgaria. And big thanks to everyone who made this event possible. Thanks for you out there watching this, joining in person. It's really important. It's great to have this community of people that are interested in learning, sharing information. And, maybe next year we'll be in person. I hope so. So the flank stack, aiming at cloud data engineers, but whatever you call yourself, there's a lot of different titles out there. Most of us are wearing multiple hats, doing a lot of different work. You could be a data engineer, you could be a programmer, you could be data scientist, developer, architect. We all tend to be doing a lot of different work, and when you're doing these things, you're usually not doing it by yourself. You got a lot of different users. Be nice if everyone used the same tools, but there tends to be a lot of frameworks, different languages, maybe different spoken languages, different clouds, lots of data sources, clusters everywhere. I try to organize this into three things. You got you, the person I'm talking to today. We'll call you a cloud data engineer. Maybe that's a better title than you have now. Maybe it's not. Maybe you've done some ETL. Maybe you've done some Python or Java. A little bit about databases. Maybe you've done a little streaming. Maybe not. You use some of these cloud tools, which is mostly, AWS, CLI, boop, boop, boop. Or you could be a cat. That's my cat. He is an expert in ETL. He likes interacting with the Edge cameras. Doesn't have any coding skills, but I can still teach him to do some of this stuff. He does question why I'm spending all this money on cloud resources when I could be buying more fish. And then AI, one day it will be our boss, but right now it's running my Apache NiFi for the data ingest. Be running inside of Kafka streams as things are passing between topics. Could be running in my new favorite Apache Flink, and could be running on the edge with our different agents. So that's running everywhere, probably in your TV. So I would like to show you all of this in open source, and the main place to get these great tools is Apache. They have a lot of great tools and frameworks. They're all open, well documented, lots of examples, great community, great ecosystem. ApacheCon is coming up virtually this year later. I recommend you join it. It's a free conference unless you want to donate money to the Open Source Foundation. And there's a lot of there's a lot I'm missing here. There's other ones you could definitely incorporate, but these are ones that come up in applications pretty often. OpenNLP for doing natural language processing, Minifies for my agents. MXNet and some of the related frameworks are great for doing machine learning and deep learning. NiFi is where I do the start of this. It's sort of my center point. It's the gateway. It's the router. It's where I grab my data, change it, query it, move it around. Pulsar and Kafka are ways to send messages around, share them, make sure they're durable. Very valuable in any of these open source projects, especially when I'm dealing with running in different locations. Like I have devices that are somewhere. I've got a gateway server that's probably nearby, maybe on premise, maybe that's cloud, maybe that's in another cloud, maybe it's in a Docker container or Kubernetes. So I've got to start communicating, sending messages around. Maybe I've got a ton of different places I'm sending that to. Maybe I'm sharing one data feed with a number of partners or different universities. Kafka and Pulsar are good ways to distribute that. Flink is a really powerful system for doing distributed programming, and it has rich support for continuous SQL, which makes for some really cool apps. Tika is pretty amazing if you have to change different types of data, because sometimes, my event stream today is JSON data. Pretty easy to process, but sometimes it's a document. Sometimes it's a PDF, sometimes it's Word, Excel, strange image formats. Maybe there's text in an image I want to get. Tika does so much. That is a very powerful one. I might want to store the data. There's a lot of open source options, certainly something simple like an object store or something like Ozone or HDFS on top of that. But today would use a little more powerful systems, and I mostly do Apache Kudu today. That is a great way to store your time series data, but it still looks like a table. I could still do my selects and orders and joins. Very easy to use, runs in the cloud or in premise. Very, very scalable. We could also do that with HBase or Hive or Impala. Lots of options out there. Iceberg. The laundry list of open source SQL and NoSQL tools is, we could spend an hour just going through those. I'm also going to show you Apache Hue, which is a very simple but powerful way to query your data. Because how do I know I got it? I want to see it right away. Do that in a very easy web UI. Hue is my tool there. So we talked about deep learning. I won't go too deep into this, but if you are doing Java, which a lot of us are, this tool is amazing. DGL AI is on top of MXNet and on top of now a number of other deep learning frameworks. So I could use MXNet, and then if I want to change something, I could do TensorFlow, I could do PyTorch, lots of options there. The coding is very clean, easy to use. I've integrated this with Apache NiFi, so as I import images that come from edge cameras or from public sources, or you're walking around somewhere, or I'm doing it with my camera, get those images, and NiFi can run some classifications on those in stream. That's helpful. This same framework can also be used in anything that does Java. So Kafka Streams, Flink. It makes sense in NiFi and Minify because I'm dealing with structured, unstructured, and semi-structured data. Usually I'm not putting images in Kafka. That might be an HDFS, might be coming out of file system, might be streaming from a camera. NiFi is kind of the sweet spot for that. I'll go very deep into NiFi, but one of the main things that differentiates it from other ingest and streaming tools is it doesn't care what type of data it is. It could be a blob, it could be binary, it could be an image, Word document, PDF, text file, a log, JSON, Avro, Parquet, XML, CSV, so many different types. So it makes it very flexible to be acting as your universal gateway. That's why I show you that. If you learn one thing today, it's download NiFi, start playing around with it, use it as your tool to get things started. So I have a link to a number of presentations I've done on this, and I'll be doing another one this year at ApacheCon, showing you how to do all this with the open source. It makes things so much easier. There's things to pick out, all kinds of pre-built models out there, so you don't have to be a data scientist. If you have someone who is a data scientist, they could share a model for you, and you could easily put that into production. Very powerful. Also, part of this flank is the edge, and that's Minify. That I'm running, for example, on a cheap Raspberry Pi, but I can run that on industrial hardware. I can run that on a server, an old desktop, pretty much anywhere. It's either in Java, so anywhere there's a JVM that's JDK 8 or higher, or there's a C++ one you could build for your different environments. I've got them running on NVIDIA Jetson, NVIDIA, different platforms that they have at the edge, and those work really well and fast. I've got links to some articles here, so if you're interested in this side of it, you can go really deep and ask me questions in the chat or somewhere else later, and we'll get to that. So what am I using those main tools for? I've got data sources all over. Today we're focusing on the edge, but the edge could be a SQL server somewhere. It could be Oracle. It could be, something coming off of a truck. So towards that, I want to get as close to that edge as possible to get to that data. There might be firewalls. There might not be any way for that device to send data out. Maybe it just writes to a file. Then I'll install a Minify Edge Agent or maybe NiFi there. It'll read that file, maybe encrypt it if you need to, maybe zip it, maybe look at it and run some analysis at the edge to say, no, I don't need to send this data on. It's junk. Maybe I'll do an aggregate on it. Maybe I'll send you an update once an hour to say, hey, nothing's wrong here. You don't need to waste your bandwidth. And then often I'll have, say we're in an airport, so that was the planes out on the field. Maybe I'll have a couple of servers in there, do some local processing. Maybe some data doesn't need to leave for security or other reasons. And then maybe some of that data streams to my main clusters in different clouds, and I can run a NiFi cluster there as well. That's often how we do it, and it's seamless to you. It takes you no more work to have everything on one server as it does to have on 3 different clusters spread among 3 different cloud infrastructures. Very easy, but important when you're thinking of what you want to do. So this is my device that I'm using for the demo today. I have a lot of others, but this one is a nice mix. It's just a Raspberry Pi, but it has some sensor readings on it. It also has some deep learning abilities there. It also is grabbing data from a energy capture device I have here. So it's grabbing those 2 sources of data to show you we don't just have to grab one event stream at a time. We're getting this device data. One tip I want to give you if you haven't done IoT before and you have this open source control to do whatever you want, grab as much data about that device. So when you're doing debugging and when I store that data, I know this came from edge device with a name, a MAC address, the temperature, how much disk space is left. That helps me do things on data health and a footprint in case someone tries to hack into your network with a bogus IoT device. I can have a list of approved MAC addresses, and hardware configuration. So if it looks different, I can run machine learning to say, hey, this is not my device or something's wrong. I'm going to check in on that. Did someone compromise a device that I have somewhere in the field? Maybe, maybe not. So I got it in the edge. Then I'm running a small gateway NiFi in a local private cloud. It could also run on a laptop. Lots of ways to run NiFi very easily, whether it's standalone, just run it with a local JVM, or spin it up in a Docker container. And then from there, I can push it to different data stores like Kudu or HBase. I'll show you. You could send it pretty much anywhere you want. You tell me, Tim, but I have Mongo. Okay, push it to Mongo. It's no no more difficult, and I'll show you how to do that. You'll find out we are very we don't care. We're agnostic for where we store that data. Store it as many places as you want. You want to store it in 50 different data stores? Go for it. No extra work for you, really. And then from there, I do a couple simple visualizations because you have data, people want to see it. Just something that happens. So I have it in NiFi. I could be done now. I grabbed the data from the edge, did some cleanup and conversion, store it in a data store. Everyone can query it. I have a report. But what if I want to do more complex analytics? What if I want to distribute it to different groups within my company or to different companies, partners? Maybe people are buying my data. Whatever. I want to distribute this to Kafka. Maybe I want to also, someone else is loading data, or there's another server and other devices, and I want to grab that data and do some more processing with it or combine that data together. Got a couple different streams of data. Kafka or Pulsar work here. You probably want some kind of schema registry so everyone agrees this is what the data looks like. These are the fields, they're their names, their types, are they nullable? That makes things very easy for people to have a contract on what data should look like. How can I work with it? It also makes it very easy for me to be able to run SQL queries on it. So that data is an event, it's JSON, it's coming in the system. Maybe I cleaned it up, maybe it's a different format now. It validated and matched against a schema. It's in a topic. It's distributed to different clients and different clusters. One could be Flink, one could be Flink SQL, or it could be Spark, or it could be your Python app or Spring Boot, whatever you're doing. But for this example, I'll show you, I read it in with a Flink SQL application because it has that schema, so it knows what fields to do. Hard to do SQL on something if you don't know what the data looks like. So that's why we have that definition there. Underneath, I've got some things that are open source, but Cloudera has with Apache Atlas. So I have security and governance. I could see what's happening with my data. Again, I could also store it again in a different format or in a aggregate in some other data stores. Very easy. Doing pretty simple data today. This is, you could see this is a pretty inexpensive environment sensor that you can get from Pimoroni over in the UK. And you plug that into a Raspberry Pi. And now you could start capturing a number of different sensors on there, which is pretty awesome. Get a bunch of sensors there in one place. A good application is this: is take this, attach it to a battery, put it in a vehicle, put it in your bicycle, ride around. If I was in Bulgaria today, I'd probably have done some sightseeing yesterday, carrying around my sensor in a backpack and get different temperature and different readings out there. It'll give me altitude. It'll give me, I could have hooked up a GPS, humidity, pressure, just a couple different values. And if you look here, we've also added the ability to gather some of those device settings we talked about. So I've got the unique ID of the device, I've got things like disk space, memory, MAC address, host name, system time. Try to grab as many times as you can. So when you're doing the final work with your data, if something got out of order, if some data got dropped. The more you have, the more you have to work with. If you ultimately don't need it, you can filter that out at some different stage, but try to capture it as many timestamps as you can. So we've got a bunch on that little, you saw that little thing there. We've got a ton of different sensors. Markups. These are the same as you could get in industrials that aren't in this one integrated device. Temperature, pressure, humidity, light. Proximity, again, is a cool one. Again, if we were doing some sightseeing. Checking out different gases that are in there. That one's not too sensitive. Having a microphone. So if I want to detect, oh, it's really loud over here. And a little display. Maybe you display your IP address. Maybe you display any alert on there. Again, depends on your IoT use case. Wanted to show you an example of a query. Now this is a query joining together two Kafka topics and doing it on a where clause when they're on the timestamp. But I could join on other things, and I could use ANSI SQL join semantics. So if I wanted to do an outer join, I could do left outer join, blank on blank, that sort of thing. This one's doing an insert. I'm going to use a tool called SQL Stream Builder, so I don't have to go through that extra step. It just uses a built-in sync to do that. I'm going to dive into the demo now. I leave this placeholder here to show you what that looks like. And let's go into NiFi. But let's start from the beginning. This is Apache NiFi. This, if you notice by localhost there, is running on my laptop. It is a very easy to use system. As you see here, this is not an architecture diagram. This is the running live app. It is a drag and drop style application. This could be a cluster of 100 nodes, process millions of events a second, but it still has this very easy to use drag and drop. Or if you're the type of person who likes to do things programmatically, there's a command line interface, there's a REST API, and my friend Dan has built a nice Python wrapper on that. If I wanted to add some additional processing, I could just grab a processor here. As you see, there's 350 of them. There's more out in the open source. A couple of these are ones I've developed for things like grabbing a local camera, doing some NLP, doing some TensorFlow, different deep learning processing, those sort of fun stuff. But this is where you could do a lot of different things, like if you need to interact with Amazon, ton of different things there. Azure, lots of different things you could do with the different systems in Azure. Again, we could keep it open, so if you need to run in different places, you can, but we can run in Windows, we can run in Linux, we can run in Azure, connected to different data sources there. We've got things for like Windows logs, depending on where you're getting your data sources from, just to give you that option there. And we have a menu over here that gives us access to a whole lot of different things. And we'll go through that since we have time. I'll show you what we're doing. This is showing me everything that's running on my cluster. I can see I only have one thing running, and there's some records waiting there. I can see any connections out there that are open. See any outputs in the same. I could do sorting. I could sort by size and see this one is running and how much data is there. Same here. That's that same port. See if anything's remote. You can see different connections. Is there data backed up? There's data waiting for me in a couple different places because I've paused things. The nice thing that you can do with NiFi is pause live systems. So say you need to change your data while it's running. Very easy to do that. Here they keep some records of things that are coming in, And everything you see here, I could turn on watching my developer mode in the browser and see all these REST calls happening. So I could go, oh, that's the REST call. Let me do it myself with curl, just to give you an idea. This is data provenance. I'll show you this once we start running our app. This is really cool. Now, what happens when you're running these distributed events? How do I know where that data looks like, what's happening, especially as I'm building out these flows? I know what the data is when it came to me, but what is it at this step? Did it really arrive? What's going on? That sort of thing. Here I can have some things that run on the total process. Here we've got some for doing reporting. So in case you don't want to call that REST API or look at logs, you can set up these reporting tasks to do things like look at parts of your running flow and send some metrics somewhere. Send it to Kafka, send it to a file, database, that sort of thing. Now here is where I'd have a connection to version control if I wanted to do that. Down here, this is very cool. Parameter contexts are separate from your flows. So I write an app and I write parameters or settings and I can apply them together when I move them to production. So, the only the DBA maybe sees passwords. Makes it pretty easy. Okay, that's the main things in there. Let's see the actual flow. Everything can be laid out differently. This is within what we call a process group, and I've got a bunch of different ones. These process groups can all live as separate entities. So I right-clicked on here and I have a bunch of settings. So I could download the code from here that easy. Or I could do things like empty out all that backed up data. I could see what this has been doing in the last 5 minutes. Not much going on here because I've got things paused. And we're going to start unpausing that. So here is something that might be interesting to people. This is a universal REST endpoint. I set this up by putting a path and a port. If I wanted SSL, what do I want to allow come in, some timeouts, sizing, that sort of thing. And this is a universal endpoint for REST. I've just written a REST endpoint for anybody. I don't have to do anything specific. Whatever you send me, I could process. I could filter that down if need be. But if you need a place to throw PDFs, this will do it. Or sensors, or reading things from the field. This is that provenance. This comes in handy. Did I get data from my device? What's it doing? How big was it? Here's a unique ID. So if someone tells me, Tim, I did not get that event, I can track it. I've got a unique ID. I could track it through the whole system and say, this is what happened to it. I dropped it in this directory. Someone else must have deleted it if you don't have it there. Tells me how it got here and a whole bunch of attributes. What's cool here is with these attributes within provenance, these are available for you to code against while that flow is happening, separate from the actual content of that flow. So this is all metadata, like the file name, what host we came into, all those sort of metadata. Like this came from a file. This tells me what file. This told me what user agent called in. Pretty cool stuff. And here is the actual content. And I can look at that and say, oh, that's that data we just saw. That's that JSON. Perfect. That is what I wanted. Let me get out of that pop-up. And we'll get back to our flow. And you could see that very easy to see the data. I could see how many are coming in. And that just keeps coming in. And here I'm going to do a very simple step. I'm going to look at that user agent, because that's how I decided I want to specify which different devices are calling into me. So I get any of those. If it comes in, I'm going to route it somewhere. You see that data is just coming through the system live. Here is my main local processing. and this is working for that Raspberry Pi. And this is something unique with NiFi, is this thing right here. This is stopped. But as you see, data is still flowing. I'm not losing any data. It doesn't matter that I've stopped part of my live ingest system. So whether you do that because someone told you, hey, our database is down, don't send us any data, or you're doing it like now, I just wanted to build up some data just to make the test runs more interesting, and I just stopped it. This has a queue, and this queue is configurable between each step. Like, let me show you that here. I'll stop 2 of them, and now I can change it. And it's things like prioritize. Let me prioritize some of the events as they come in. You know, should it just be in order? Should it be, or is there a special priority attribute? How much data should I hold in this one? You know, it defaults to 10,000 in a gig. Maybe you have a lot of small ones. Maybe you want to load balance this between nodes. And I can maybe partition that by one of the attributes of the data we just saw. Or just do round robining. Maybe I compress it if I send it to another node in my cluster. That's up to you. I just change that live. Start that. Let's start this up. A lot of data is going to start running through the system. I could do a refresh to see that come through. And you see it's processing even though it's on my laptop that I'm also doing this recording from, that I'm also running probably some apps I should have stopped like email. But it's going through there and I'm routing it like you saw on the other router. Just looking at some values to do that. Here I'm setting a parameter so I can get a schema. And I have what we call record readers. This one is going to look at that data, infer it with that it's JSON, and then convert it to JSON. But, you know, there's other options there. I'm also doing SQL queries against that data live. And that's how I'm discerning, is the fan that I'm connecting to on or off? Kind of silly use case, but it is something that I was concerned with when it got too hot in my office here. So, but there's other types here. I was mentioning different types of data. Apache Avro, comma separated values. Again, it could be tab or, you know, pipe, other things. JSON, Parquet files are very popular. XML. I could also do things like write out freeform text or use the record set one, lets me do a lookup. So I could have a parameter that comes in and says, Tim, this time write XML. Or that time write CSV. So you can make these more generic. For the readers, we have some pretty cool reading formats beyond what you saw before. This Grok one, really powerful. This is, if you search for the word Grok, it's used in log processing. So even if it's multi-line, even if it's not very consistent, you could parse them. We could do that right here very simply. We can also read syslogs and Windows events. So it gives you lots of different options for doing that. And you can write as many of these queries as you want. If I wanted a third query that was just select fan status and unique ID from the flow file, which is any data you send me that matches that reader there, and after the write matches that schema, because I said use the schema, you know, it will give me that query in another one. So pretty straightforward. As you see here, I stop something. New data is coming in constantly. So it's sitting in this queue. Again, I could examine it to say, okay, this data looks okay. This data looks live. This just happened a minute ago. Great. I'll start that again. Starts pushing data out. And here I'm just going to send it to Kafka so I can distribute it to my cluster at Amazon. Or actually today it's in Azure. That doesn't matter. I could have both. Here I just have a parameter for my Kafka brokers. Topic name. See, this one is converted it into Avro. I could use Kafka transactions if I wanted. I say send along those attributes that have schema information as Kafka headers. So it arrives on the next side. I know what it is. I've got the client ID so I could track it better. Makes it easy. Now what happens, Tim, if there's an error? Something goes wrong. Could happen. Maybe Kafka's down. There's a network blip. I have something called a retry flow file here, and I could add this to every step. And it says try 3 times. If it fails, send it over here. I can send all my errors someplace. Maybe I send them to Slack. Maybe I put it in a file. Tons of different things you could do. Probably with errors, you want to do something that is very reliable, which, you know, maybe isn't a network. Maybe it's just to a file. So we have data we sent to Kafka for energy. That is one type of data coming from that device. There's also some images and there's some environment data. That's that main sensor data that we're concerned with. And here I've got another query here. Here I've got something. I was going to distribute the data to some other clusters, so it's just piling up because I don't want to do that. And if I don't need that data, just get rid of it. Doesn't matter. You know, here is another query, again, JSON to JSON, and I've got some parameters for SQL queries here. Like this one, I'm looking at the temperature, and I convert it to float. This is the Fahrenheit one. We also get the Celsius one. In the US, we're still stuck on Fahrenheit, but I could use the Celsius one and check it against a value. What's nice here is I can cast things. So in case they're not the right type, just cast them in the query. This uses a project called Apache Calcite, which is a very universal processor for SQL. Very helpful. So I've decided for those, I'm going to send that to this distributor. And for this one, I want to break up any bulk rows into single ones because my MQTT broker only wants small records. You know, send me one at a time. So here I'm sending it into a different Kafka topic as Avro. This is for SCADA. That's our sensors. We'll take a look at that. And I'm also sending it to MQTT. Maybe that's used in a different industrial application. Maybe a party that only deals with it. That goes wherever it wants. Again, I have the results of what happened. So you know everything that happened, what was the results. It was just one record, you know, that was successful. If it failed, you know, I could do one thing with it. If it succeeds, I could do another. You know, maybe you have something like every 1,000, I want to acknowledge it. Very easy. So we've got data in MQTT, and we've got data that went to Kafka. So let's go take a look at that. Now, the one thing also is what I didn't show you is on that edge device, besides doing some local processing, it's running an executable in Python to do some machine learning and gather some data. It's also grabbing those energy feed from a local device and grabbing those sensors. That edge agent is also pushing right to one of my cloud servers, just to show you different options, because you might say, Tim, I don't want to run anything in my local platform. It's going to go from that edge device, even if it's in my backpack, and send that right to Azure or right to any cloud or right to my server cluster. Sure. So let's take a look at that. We will go over to, hopefully this didn't reload here. Yep, here we go. Ooh, I've got a lot of ones backed up here from MQTT. Maybe I should up the size of that thing there, so now we're not running out of space. I'd pause this again, like we mentioned before, so that if I could show you a lot of data coming in. So here's some coming in from the Kafka gateway, some from the MQTT gateway, some coming in from the direct HTTP gateway. We could also have it come from another NiFi cluster with an SSL protocol. If you look, these two are the same size. This one has less because I'm sending extra through MQTT. If you look, these are smaller records. These are bigger because NiFi lets me pack multiple records in a single file if I want. Like this one, if we take a look, this one that came through Kafka is 216 records. Again, for performance, that may be helpful for you. Depends what you're doing. You know, for now, you know, like if I didn't want that data, oh, that's duplicate data, let's throw that away. Like I don't want this one. You know, you don't need that data. Or I could send it somewhere else, temporarily process it. I'm going to start this one again. I could run this once when I'm like building it or testing it, but I'll start it. And as you see here, the data starts processing pretty quickly, even though this is a small one node Azure cluster. And then I'm going to add some extra attributes to it to let me know what I'm going to do with it downstream. Again, this is because I'm making my flows generic so I can reuse things. You know, maybe I have hundreds of different data types and only want one flow. Here I'm sending some things on some attributes telling me this was energy data, this was that sensor data, and then I'm going, well, that went fast. Yeah, this just dumped 8,000 records. I'm going to send this data to a kudu table. We talked about this in the slides. I have an IP for that. I've got the table name, and it says it's JSON. That's it, and it's an upsert. You didn't see any, I didn't have to manually map SQL. It took the names in that JSON, took the schema, and knows to map it to the kudu table. That's brilliant. It's very easy. You send me different data, but it's a different table, and you give me the schema, I could do that all day. That's as much as it takes to send to any kudu. But you mentioned, I don't have kudu, Tim. Well, you probably should get it. But you can use Mongo and do the same thing. It takes in, you put in how I log into Mongo. You can make these all parameters. And then, you know, this is also JSON and whatever your batch size is. And now that one will get in that data. And I can literally grab here and have it go to both. Or I can have it, like I mentioned before, if we want to put that to Azure Blob Store or Cosmo DB or Data Lake or an Event Hub or storage. Pretty straightforward. I could put that into a lot of different data stores. DynamoDB, you know, any of these data stores you have. If it's a relational database, I can put this into anything that has a JDBC driver, which is almost anything. So we've got data kudu. If you look down the bottom, that's how I navigate. Makes it pretty easy. But you can directly go somewhere if I want to search and I know what I'm searching for. Like, okay, Kafka. What different Kafka things do you have there? I recommend you uniquely name things. So like say here I've got set sensor values. This will show me it's right here, and I go there, it's right here. So it's a good way to navigate, or if you forget where things are, or if you want to reuse code, pretty easy. This one I do have version control on, so you can see what changes I made. I upped those Q values, I turned on load balancing, so that's some different code. So I'll commit that, and now that goes into my registry, which could backs up to a database, but could also back up to your local Git or regular GitHub like most people use like me. So we have data coming in. Also, I sent it to a stream. If we look here again, that retry flow, errors, I'll send them somewhere else. If I wanted to break this up into smaller chunks of data, which sometimes I want to, especially with JSON, some things want one record at a time. I could do that pretty easy with split record. If I want to slow this down, I sometimes do this for demos, so I can have it continuously going data even if my source isn't fast enough. Here I could say just send 25 a second. I could also use this with data generators. We do have ways to simulate data, so you could do your integration tests. You know, sometimes you don't always have a flow of data. Here again, pushing it to a topic. Here it passed in as a parameter, so I'm handling both types of data with one thing. And as you see here, it went to Kafka. But how do I know it's in Kafka? It would be good to see it. Here is that version control I mentioned, stored there. We talked about schemas. I probably should show you them. We have the sensor one. We have energy. We have the one we talked about, SCADA. And here I could see it. If I wanted to make a new version of this, I'd give it a description, maybe add another field. You know, here's the name, here's the type. It allows nulls. You could put things in like defaults, things that are optional, lots of things. You have different options on how you want to branch this, you know, and when you create a new schema, you can decide how it's available. Usually we do the Kafka schema group, so that shows up right when we're doing anything with that. And right now I'm just using the Avro one. There's some other schema providers if you need them for like protobuf. So we have a schema. It's defined here. It's on a server. It can be used by anyone. Has a full REST API. Great. This is how I look at Kafka. There's similar tools for Kafka in other places. There are, tools for Pulsar as well. This is SMM from Cloudera. Makes it pretty easy to find out what's going on with SCADA. This is an overview. I could see who are the big producers. This is my sensor data. How many messages have they produced recently? Here's that SCADA one. I could see some high-level output of that of the previous month up to now. I could dive into that, see some different things. But to me, the most important one is this Data Explorer. So I could see the data that's just come in. And this data is looking pretty good. And I could dive in. That looks like that JSON data. And this is Kafka's timestamp. That's how many records have come in. Seeing data. This is great. What about the energy data? Energy data, also seeing a bunch of rows there. Looks pretty good. I've got a couple hundred records here. I only do energy readings not as often as the sensor readings because the energy meters don't update that often. So don't waste calls to it. So this updates every it's either 30 seconds or a minute. And we got that in there. We got voltage and all that different fun stuff. I can see who's producing data, sort it, and see who's producing the most data. Like the sensor run pushed through 200. This producer, if you didn't give it a name, 7,000. Who's reading this data? And why aren't they reading a bunch of Kafka Connect apps that aren't running? So they got a lot of backup. I could start them if we wanted. Like I have one for SCADA here. So it's waiting. It's behind on its consumption because I stopped it. But this is a simple one. It takes the data, writes it to an HDFS directory. Nothing big. Here I've got some alerts set up in case something goes wrong because sometimes things go wrong. Okay. This is the next step. We're getting low on time, but I'm going to try to go right to the edge because I am unfortunately pre-recording this. So this is the Streaming SQL console. This is the way I can easily run queries against different things like Kafka. And so I don't have to do this as a deployed app or from the command line. It gives me a unique job name. I set up where I want this data to go. That's a Kafka topic. Or is it? Nope, that's a REST endpoint. Could be a Kafka topic. I want to keep this running, so I'm always going to restart it. And from down here, I want to sample it. I could save it, so if it needed to be restarted. Here it's showing me some recent data from the last time I did a sample. And what's nice here is, that's it. This right here, maybe we'll make it easier format to see. Maybe not. What's a better format? It's a little easier to read. And this lets me run the query against as many of these topics or different things as you want. I've got a bunch of these defined as tables. What's nice is outside of a couple of them that I've added, these were ones I added manually. And what's cool here is these were pretty simple. All I had to do is say, I want to add a new, say, Kafka topic. Point to my cluster. Gives me all the topics. I know this one has data in it. We'll just do that. Give it a random name. I'm going to detect the schema. And then I'm going to send a name for a consumer group. You always want a name when you're doing Kafka so that it knows where you were last time. So that detect schema looked at all these fields and guess what the type should be. So now I can run queries on it. Pretty cool. And then when I save it, it ends up like this one. And it's a table. I could run queries against it. And if I wanted to manually build this table, it gives me all the SQL syntax for that. I also created a webhook, and that one we got to dive into and take a look at. Here's the name. Here is the endpoint, and this could be anything. This happens to be NiFi, because NiFi is pretty good for being a universal gateway. So I just pick any port that I specified at that REST endpoint, spec the what I want to call it, or nothing. I'm doing a post. I don't have SSL on. I could. This is telling me send that whole JSON file. If I wanted to do some processing with JavaScript in there before I sent it, this could do it there. Throw in a couple of headers, whatever you want. You could also set up a template to reformat it if you wanted. Again, lots of power on that when you're sending the data out. We also have all these different data providers. This is my Kafka cluster. I could have a dozen different ones. It could be in different places. One could be in Azure, one could be on-premise, one could be somewhere else. And then I've added a bunch of catalogs. Right now it's Kudu, Hive, or you might be able to do a custom one. These are the ones that make sense in the schema registry. So Kudu, using that Kudu server, gives me a list of every Kudu table that I have, which are those ones you saw me populate. Schema registry, same thing, connects me to all the ones out there. And then when I go into console, like here, I could write a new query. I have those. These were auto-imported, so I could select against any of these pretty easily because they're in there. So if I wanted to run a query against this guy, I just copy that in. I could do this if I want to see what it looks like. That's what it looks like. We already had that on the other screen. But I could just do a select star from this one. This is a table, so this is not really an event stream. But to give you that idea, what's nice is that just launched a real job. If we look over here, this was the nifty one. And then, is that one done already? That's still running. And then we could just go and see the dashboard. We also have the ability to take those runs and make them into a materialized view, which is really cool feature. And here it gives me the link so I could use this to connect with a Jupyter notebook, import that data, use it in some Python, or click here and I can pop open a new window to show it. You have API keys for as many as you want. Pretty easy. Here I could define any functions in JavaScript. I could use, these can call out to Java code, since this is JavaScript running on Java. And it shows me the history of different queries I ran, and I could see all the different jobs that I've been running, what the query is, where it's going, what's the source. Helpful stuff. And then I can go back in there and edit it if I want. I could build a new materialized view if I wanted. I already have one. But if I wanted to add, say, another one, I could just give it a unique name, maybe put a description, pick which columns I want. Now here, I want every column returned, but maybe I want a filter, where this column is in, this set of data. A whole bunch of different filter rules, and these can take parameters in. So you want to pass in a parameter that says, just give me disk usage. You can make a pretty full REST app. This is a materialized view, and you see here that keeps that data for a number of time. So as that continuous data is coming in, this will keep a cache of it so that I can call in from a mobile app or whatever. This is a great way to do dashboards, Python, wherever you might have. Makes an easy way for you to take this continuous query, make this into a REST accessible data. This is that REST endpoint, that materialized view. This is an example. This one has a lot of data because this is the last 300 seconds worth. I didn't limit it. I could have. As you see here, it's JavaScript JSON array. Easy to process that, especially in NiFi if you wanted to. This is that job running in Flink, and you could see what it's doing, where the source is coming from, where it's sending it to that webhook, how it's running, seeing all the metrics, records as it's processing. This is running in a yarn cluster, running wherever it is. This could also be in a near term be running in Kubernetes. Again, on the cloud or on premise, doesn't matter. I wanted to, let's see if I'm still logged in here. I wanted to show you some of that Apache Atlas there. Atlas gets data from Kafka, Flink, and NiFi to say who's doing, who's doing things with my data. And that's helpful when you're trying to track these complex things along distributed apps. So like here, Energy 2, who's popular, where did it come from? It came from that listen in NiFi, it got routed, and then got pushed to this topic. It also had a second source. Came from the Energy 1 that was running locally, got consumed, and got pushed to another topic. This is nice. This shows you all the auditing. If I put it in a table, it'll show me that. Very easy for you to do these sort of things. You can see here the SCADA one comes from MQTT, goes through 2 different forks, get pushed to another Kafka topic, or through listen, or from that other Kafka topic. Pretty easy to do, but shows you an idea of what's happening with my system. I could download this and give it to someone and say, this is my architecture. Very nice. We wanted to see the data in Hue. Here's some of that data. Let's see if we've got any new ones in the last query I did. Yeah, there's a couple of new records here as we pull in the data. And I could do things like order by system time descending, so I could see the newest data first, which is nice. Yeah, this data just came in, and that's very helpful. I also have some very simple reports, as that data comes in. Nothing too fancy, but shows you could push it into maps. We're back to we're running out of time here. So let me get this, get your takeaways here. IoT is easy if you use open source. Download my examples, start working today. Start with a single device, don't try to do 5,000 at once. Try to capture the data locally, test it, make sure it looks okay. Send that data to whatever cloud, especially Azure, securely. You don't want people losing the data or hacking it. That data provenance, debug, monitor, see what's going on. Share your work with the community. Great way to do that. Here's links to all the source code, and we'll publish that through everything we did there. Some more deeper articles and additional examples. And remember, all your data flows belong to us. Upcoming events, really cool in the next couple of months. There'll be links to them in other talks. These look pretty cool, and they're in different times and cities. Please check them out. Thank you for everyone who made this event possible, especially Microsoft and some other vendors there. Thank you for making this possible. Thank you for joining my talk. Hopefully you found it interesting. Thanks again, and hopefully I'll see you next year in person.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. Check my stock. What a shock. Prawn. Ovens on. Coming future zone. All for me. IoT. 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 Live like a Bosch with many connectivity for a smarter future. From Bosch.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings, as well as a personal budget of 1,024 BGN, and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below. Start my days, sun rays. I tap
tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one. These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, IoT, IoT. IoT, I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT. 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 Live like a Bosch. With many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще има $1 милион висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1,024 BGM,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, IoT, IoT. IoT, IoT, I check my stock, what a shock, buy some prawn, my oven's on, coming home, future zone, all for me, IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one. These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heating smart, I do my part. Get in the car. Superstar, they're watching me. IoT, IoT, IoT. IoT, IoT, stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT. 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 Live like a Bosch. With many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1,024 BGN,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
start my day. Sun rays, I tap the phone. Coffee's on, I mow the lawn. Impressing Sean, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car, superstar. Me, IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1024 BGN,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
sun rays. I tap the coffee's on. I mow the lawn. Pressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart. I do my part. Get in the car. Superstar. They're watching me. IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT. 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 Live like a Bosch. With many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Good afternoon, everybody. My name is Radu von Vulea, and for the next 40-45 minutes, we'll talk about message communication patterns. I want to draw your attention that it is not enough to use a product that is offering a strong message or event-based solution and handles messages and events very, very well. No, we also need to be aware and to implement different patterns on different way how we consume and process messages on the producer and on the consumer side in such a way to cover all the things that can happen during the life cycle of a message. Who am I? My name is Radu von Vulea. I'm based pretty close to you. I'm based in Cluj-Napoca in Romania. Usually, or before the COVID, it would take me around 2 hours and a half, including changing the plane in Bucharest, to come to you, to Sofia. I was in the past many times. I think that in the last 5 years I've been 1 or 2 times at least per year, and I really enjoy Sofia and hanging time over there. Thank you for the invitation, for delivering this session. What you should know about me. I'm working for a company called Endava. I'm also Microsoft Regional Director and Microsoft Azure MVP. I started my journey, I think that the IT journey, or as a developer, I started the journey around 17 or 18 years ago. I don't even remember when was my first real project and that for which I was paid. And in 2010 I started to work with Microsoft Azure, and from that on I worked with Azure, with AWS, and starting from 2014 being more and more involved also in different IoT solution, connecting smart devices and so on. One of my personal hobby is working and making my house smarter. In 2015 I started to work on my own platform that worked pretty nice, and basically I was building my device by myself using ESP8266 microchips and relays and different sensors and so on. And in 2020, staying a lot of time at home and deciding that I want to grow and I want to expand it, I realized that a custom solution, it's not so nice because you need to do a lot of integration, and it's not so easy to integrate with a lot of devices and to write all the things by yourself. So what I've done, I started to use home assistant solution that is an open source solution and works very nice with a lot of devices. So I think that I have more than 12 or 14 different producers of devices, of physical devices, plus the ones that I've built by myself. And I integrated them through ESP Home. Or I, for example, overwrite some firmware of some devices like switches and plugs, just to be able to have all the communication inside the house. For example, even the car that I own is integrated inside the platform, and I can see the battery level, how much it consumed in the last trip, where the car is located, if the charger is connected, how much, and so on. Some other thing that I'm doing and I really enjoy, for example, is how much energy I'm consuming on my working desk from my home. For example, at this moment in time when I'm doing the recording, I'm consuming around 46 watts per hour, and the total consumption in kilowatts for this day was 0.3. That's pretty cheap. So I realized that usually I consume around 0.5 kilobytes per hour per day, so which I don't even want to think about how much energy I'm consuming through the air conditioner system that is running nowadays almost all the time because of this over us. If you want to contact me or if you have question anything, just drop me a line on Twitter or on LinkedIn. It's very easily to find me, and we can have a chat or on any other topic. So what we need to expect in the future? Well, by 2025, it is estimated that there will be more than 21 billion IoT devices connected. Now, when we're talking about IoT devices, this can have multiple definition. Can be a wearable device that you use at your home and or where you are doing jogging or when you go to work. Can be even your car or a factory device or some robots or some devices from the factory. Can be the smart doors from the shop and things like that. A very interesting thing that we are not aware of is that, for example, retails there are retail shops on in Europe when the notification that a new house will be open to be able to pay your groceries or the products. The decision, the announcement, and the selecting of person that will go on that desk is done automatically. Basically, there are smart cameras that are doing the counting of how many people are in the shop, how many people are in the queue, and decide automatically to open or to close a desk. And with the current technology that we have on the market today, it's very easy to do that without too much hassle. What is our main mission for today? Well, I want to make you aware of two things. The problems that can appear when you're using a message-based communication, and also different ways how you can handle them. How you can handle this kind of problem using the patterns or some best practices. This is the agenda. It's pretty simple. We'll start covering initial patterns. After that, how we can handle reliability and availability when we are using a message-based communication solution, and in the end, a small comparison between message and event-based, because I see it very often, and we need to take into account that message-based communication is the same as event-based communication, and even if there are some features that are common, there are some small flavors between the two of them that can impact us and can impact our decision, what kind of things we want to use. Now, why message-based? Well, let's take a look on this picture. What you can see. A highway intersection of two different highways that are very well connected between them, and also some other small roads around it. I'm more than sure that at the moment when this crossroad was built, it was overestimated, and they say, oh, that will be fine, can handle the traffic that will be generated. But the reality is that it's not already or it cannot already handle the traffic, and also the impact on all the things around that is pretty high. The same thing it is when you're working on a message or event-based solution. You need to be very careful how you define it, how you will scale it, and what is the impact on the solution by connecting different systems on a high throughput channel. Because that channel can generate also a lot of noise on the end, on the producer and on the consumer side, and also on the network layer. And you need to ensure that also the network layer can handle that. You have enough bandwidth, internet bandwidth, to be able to connect the producer and consumer to. So there are also other things that you need to be aware of. Not only what is the solution that I will use to do the communication, because sometimes it's more easily, as for example when you're building a highway. Building the highway itself is not a big deal. Connecting the highway with other roads can be a little bit complicated and can generate a lot of noise. And yes, will use a lot of space. So let's dive. Let's talk about patterns. The standard one that are very often used: synchronous communication, HTTPS, asynchronous communication, queue, pub sub. When you're talking about queuing, think about it as just a simple receiver. Basically, you have a consumer and you have a producer. And it's point-to-point communication. There's the message that is generated and it's sent by the producer, or the time we receive only one time, one consumer. You cannot have the same message received by multiple consumer. consumers. Problem like send message multiple times, one-time processing, or having issues with the message order are very, very common. Now on a PubSub or a topic subscriber approach, you have multiple receivers, meaning that you have one producer that is generating the message. But you have one, two, basically you can add dynamically the consumers. The producer itself doesn't know how many consumers will be. It is not his job, basically he's just sending the message. On the PubSub solution, the broker itself, we could say that even it duplicate the message for each consumer that is registered. The issues, the problem that you can have with the same approach are the same as you can have with the queue. Send message multiple times, one-time processing, and the message order. And let's start and let's talk with the message order. What is the message order problem that can pop up? Well, the producer is generating the messages in the right order. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Something happened on the wire, and the consumer is receiving the messages in the wrong order. 1, 2, 3, 6, not 4. There are cases where, from the business point of view, the order of the messages is very, very, very important, and you need to be able to handle that. You need to be able to put the message in the order that was previously. How you can do what you can do to be able to do that. In most of the cases, the queue or the PubSub solution that you're using already have support for message order, and some of them can guarantee it in some situation. So it's almost 100% inside here, but sometimes there can happen some overlaps, and the kind of situation they cannot guarantee the order. Well, the most simple solution, what you can do, you can have a cursor, a sequence, or a position concept, and work very well when you only have one or let's say two producers. But when the number of producers is high, it's pretty hard to be able to have the position concept, because basically you need a counter that is shared between all the producers to be able to put a number on each message in such a way that on the other side the consumer to be aware of it. Another approach that can be used is based on the timestamp of the message when it was received on the message solution, and to use another service that would automatically be able to do or to put a message in the right order. In this case, you need a cache or a temporary storage where you would put or you would store the message until it will come until you will process his position, and you can push it forward to the queue that is in the right order. What about dead letter queue? Now the problem with the dead letter queue, I would say, is that that we don't have support for it, is that many people are ignoring or are not aware of it, and they end up in production and they are shocked that, oh my god, we have also dead letter queue concept. What does this mean? How we can handle it? What does it mean, first of all? Dead letter queue is referring, especially from the consumer side, when the consumer is processing the messages, like we have now message 1, message 2, message 3, 4, 5, and message 6. And the message 6 has an error and doesn't allow the consumer to process the message. And in the kind of situation, we can have a situation where the consumer tries to process the same message over and over again, blocking the consumer instance. What we can do to be able to handle it? What we can do to avoid this loop on the consumer Sometimes, I would say 90% of the cases, we have support from the message service itself. It has support for the letter queues, meaning that it can automatically detect if a consumer tried for specific time intervals to process the message, and automatically it will push to that letter queue. Once the message is pushed to the letter queue from the main queue, the message is not available anymore, but you can have here another consumer from the monitoring team, for example, a service that will take automatically the message and generate an alert or notification or an error that can be processed later on. Other situation can be when you have multiple versions of messages with different formats, and you want to do some transformation of the message to be in the latest format, especially when you need to support multiple versions. And in this kind of situation, what you do behind the scene, you can use the letter queue and the service to do the transformation, and after that you are pushing the message back to the main queue. If you don't have support for things like that, well, you need to use a secondary service. And in the service itself, you need to have the concept of counting how many times you try to consume a message. And if you identify that you are not able to process a message for 3 times or for 6 times, anything like that, then you will automatically push a message to a so-called letter queue that would do the same thing as you would do on a standard letter queue. This is a little bit more time consuming, but still can be done and can be handled by itself. The thing that you need to be aware here is that you might need here or near the service, if you don't have support for the letter queue, a cache or a temporary storage where you would do the counting for the message that you are not able to process. In such a way that, for example, if you are not able to process the message for 3 times, you will consider pushing the message to the letter queue. What about sending the messages multiple times? You will say, well, this cannot happen very easily. Well, it can happen. If you have connectivity issues, for example, between the producer and consumer, and the producer doesn't receive the confirmation that the message was sent with success, he might send twice the same message. And you don't want to process on the consumer side the message twice, especially when you're running or when you're executing different commands. What you could do, what we can do related to that. First of all, we have the duplicate detection mechanism that nowadays is very common, but we need to be aware that there are 2 things that duplicate detection affects us. First of all is the size. If, for example, we start with a queue that has 1 gigabyte and we know that we can have 1 million messages stored in the queue. Once we activate duplicate detection, depending on how long we consider a message that was duplicated with another one, it will affect the size of the size of the queue that is available for new messages. Because also the older messages that were processed, but you consider them that was duplicating because in that time interval you don't want to have 2 messages with the same content, will be stored. Even if they are not available for the consumer, they are still a part of them stored. Can be the full message, can be only the can be only how you call it. I even don't remember the name in Romania. The ID of the message or thing like that, but basically you are storing something for that message. Another option is to do the duplication detection on the consumer side. It's very tricky, especially for high throughput, because you will need to use or you need to have a repository where you would store the ID of the message that you processed, and to do some checks for each new message that you're processing, and also you need to have some mechanism to do the cleanup. So it is possible, but taking into account that it's very expensive, especially from the CPU point of view, for high throughput solution. What do you do, or what do we do in the case of an outstage? Don't think about an outstage on the producer or on the consumer side. No, no, no. Think about an outstage on the message queue. We can go into an approach where we have an active passive replication. What does an active passive replication means? Well, we have two queues, one active and one passive. The producer is sending all the time messages to the active one. Nothing more than. The consumer is listening and is consuming messages from both queues, from the active, but also from the passive. Maybe from the passive, he will not try to consume messages every 1 second. Maybe he will do the check every 10 seconds or 1 minute and so on. But still, he needs to listen on the both queues. In the case of an outstage, the active is not available anymore. The producer automatically detects that and will start to push the messages to the passive queue. From the consumer point of view, there's no change because he will just consume messages from the passive one. Now the challenge is when the active go back online, what you want to do, how you want to handle that. Are you switching the passive? Are you switching the communication from passive to active back, or you are keeping the passive and you make the passive active one? It is pretty hard to have a solution that you say that can be used for any situations, because you might have from the throughput and resource reservation, you could have a higher tier that is more expensive on the active one, and the passive one that you're keeping on for backup, just a very basic tier, just to ensure that you have business continuity and nothing more than that. On an active passive replication, there are three main reasons that you need to be aware of. Message delays, because the switching from the consumer from active to passive might take a little bit of time, especially for producers that could try a few times on the active. Message lost, because once the active goes down, the active will go down also with the messages that were stored there and were not yet processed. And message duplication, because if the active goes down at the same moment in time when the producer is waiting the confirmation, the knowledge that the message was received with success by the producer, the producer can decide to send a message to the passive one also. So you have the same message, send it twice, and once the active will be back online, you need to decide if you will still process the message from the active one or you will skip that. Another approach is active-active. It's a little bit similar with the active-passive, but the producer is sending all the time messages, the same message, to both queues, active 1 and to active 2. The tier for these two queues needs to be the same, to be able to handle the same amount of money, because basically you will duplicate all the messages that the producer is sending to the consumer. You will duplicate them twice, for active 1 and for active 2. On the consumer side, you need to be able to process these messages. You need to be able to consume the message from both queues, active 1 and active 2. And on top of that, you will need to have a mechanism to do duplicate detection, maybe to store the ID or the hash of the message, and if the message was already processed, to skip the message that you are processing from the secondary queue, from the active to queue. So there's more CPU that is involved, and sometimes for high throughputs can become pretty expensive. When one of the active goes down, nothing happened from the business point of view, because all the messages were also sent to active number 2. So business goes as normal, and once the queue that was down come back online, well, you just go business as usual, and you're just sending and consuming messages from both queues. What are the risks? First of all is the duplicate detection that can that sometimes cannot be very easily achieved, especially for high throughputs. You need to consider the extra cost of another queue, and also the CPU cost to do the duplicate detection. It automatically generate, and we need to expect additional computation power that we will use. If we go with a cloud solution, money, but if you're an on-prem solution, you need to ensure that you are you have enough reserved to be able to do this. In the case of an outstage with a limited budget, because not all the time the customer has, let's say, 30% more from the amount of money that is used by a producer and consumer and the queues themselves, or by the service bus. So what can you do in the case of an outstage when the budget is limited? It is pretty clear how much budget you have. Well, an active standby approach and active standby replication can work very well and very nice. What does this involve? Well, we have the producer, we have the consumer, and we have only one queue. We have the active queue. The producer is sending the messages to the active queue, and the consumer is consuming the message from the active queue. In the case of an outstage, we have a script. Can be an AWS Lambda, can be an Azure batch, an Azure job, or an Azure function that automatically spin up another queue, a standby queue. Can be another one that will be consumed, can be a temporary one that is kept until the active one goes live again, depending on your business needs. The problem with this approach is that spinning up the standby will take a while. You might notify that during your test it takes around, let's say, 30 seconds to spin up a new queue if you're talking about the cloud, a cloud vendor like Azure, but there is no SLA related to how long it would take. Can take 10 seconds, can take 30 seconds, can take 1 hour. Because of this, the communication channel that is based on the queue or based on the service bus or anything else will not be available for the given time. And you need to be aware that this is a risk that needs to be handled and accepted by the business stakeholders. So the solution will be offline for a specific time interval. There will be a time delay. You need to be aware it goes up again if you still want to process the messages that were in active. And the resource availability, especially in the case of original, because you know the one that will fight for the same resource. And in this kind of situation, the time period for how long it takes you to spin up a new instance can be much, much higher. Now, what we do if the consumer is down and we have some stuck messages because of that? What does this mean? Well, in this kind of situation, we have the consumer broker, for example, that is sending the message to the right services or to the right components, but one of the components is down. So he's trying to consume the blue message over and over again, but it cannot be processed with success. In this kind of situation, we are stuck with a message. The message is valid, the message is good, but the consumer, behind the scene of the consumer, we don't have the right tools to be able to, and the right service available to be able to consume the messages. Well, we need to do a message deferral. It's for messages that cannot be processed, and we need to decide exactly what we want to do in this kind of situation. We can use a delay queue, one of the options. What does this mean, a delay queue? Meaning that we have a queue, we have a secondary queue where we are putting the message for a specific time interval, and after that we are pushing back to the main queue. Sometimes this can be done only through the configuration from the delay queue and main queue. Sometimes you might need a service here and to play with TTL. This is how you can handle it on RabbitMQ for example. For other solutions where where you can hide messages for a specific time interval, like for example for service bus, you can just set this flag to the message and make the message not to be available for a specific given time. So the day-to-day issues that we have are numerous. We can have issues with duplicate detection, with the session, with the dead lettering, batching, transaction, filtering, and action. So a lot of things that we need to be aware of when we are working with message-based solution and event-based solution. Another thing that I've seen very common is that the border between messages and events is not very clear. Why does this happen? I think that the first cause of this problem is that more and more solution that used to be specific only for messages. And if you put this hand in hand by high throughput that is required, it's more easily for people to go or to say that we'll go with an event-based solution because we know that it can handle high throughput. And to assume sometimes that all the functional requirements and non-functional requirements are supported. And they end up, once they go in production or during the test, they realize, okay, we have high throughput, but the message order is not guaranteed. And what we need to do? And then you start to replace the solution or to handle that on the consumer side. When we talk about the message, is the basic unit of communication that can literally be anything. I really enjoy, or I like to compare message-based communication as message to be like a command. Because when you're talking about a command that you're sending to a device, you don't want to lose that command. From the business point of view, the most important thing is that to not lose the message itself. Versus on events, but that just inform us that inform various listeners that something had happened. If you lose 10% of the events, well, the reports might not look as good, or some dashboards of some status dashboard might not be up to date, but in the end, the business is not impacted. For example, if you are monitoring the state of a yard door or of some gates, and you're losing 5 seconds in a day of the state of the yard, and not changing the state, but for example, the yard gate is every second is sending a heartbeat to the backend saying that my state is open, or my state is closed, and so on. Losing 5 seconds per day doesn't affect the high level view, especially when in that 5 seconds you didn't change, when the state of the yard gate didn't change. Events are very, very similar from this point of view with datagrams, because they are self-contained, they have no dependencies, and they are connectionless. They don't have a connection between one event and another. Versus on messages, when you have the order, you have some messages that are related to them and things like that. So they are very similar to the datagrams, especially from the TCP/IP protocol. And basically, events are supporting data exchange and doesn't contain actions by themselves, and they should never contain actions by themselves. Now, if we put side by side the main features that a message-based solution and an event-based solution has, we need to take into account that a message has content that needs to be received with success, like a command. Or you want to process a transaction, a bank transaction. You don't want to lose the transaction. Versus an event where it's more unacknowledged. It informs us. For example, if you are sending a command to a yard gate that the door needs to open, you can receive events, acknowledge events that the command was received with success, that the command is processing, the command was processed with 50%, and the one was processed with success, and the processing finished. They're just anonymous, they're just events. As I said, command-like approach for the message, and for events is more data points, data streams. Another main difference between events and message-based communication is that for message-based communication, once a message was processed by a subscriber, the message is fully removed, versus on events, for example, like in Event Hub, where we have partitions, the events are stored for a specific time interval. And each consumer group has its own cursor. And basically the cursor specifies the position in the event stream of that consumer group. Meaning that you can go back in time, anytime, to process the same events over and over again. This is something that, for example, Twitter is doing. Twitter is storing all the tweets. Tweets are events, remember. Is storing all their tweets from the beginning, and they can go back in time to do analytics to see when something happened, to detect patterns, to optimize the way how they are selling services to their customers, and so on. What we can see here, we can see the main feature, the most common features from message-based communication and for event-based communication. With red, in most of the cases, are very, very common and specific for message-based communication. With green, the ones that are very specific to event-based communication. And the middle area, with gray, is the one that nowadays I will call them that most of the cases are common, or we can find reliable event and message-based solutions that support them, like reliable asynchronous delivery, multiple consumers, telemetric use case, at least one delivery, batching, durability, TTL, time to live, token-based access, and auto-delete. And because of this, sometimes we think and consider going on an event-based communication solution, even if the things that we are doing behind the scene are message-based specific. But because we are thinking about throughput, about speed and things like that, we go on even if you can see, in most of the cases, there are also other features that we need to consider when we go with one approach or with another one. Now, to sum up, I think the most important thing that we should remember from this session is not about the differences between message and event-based. You can go back, you can Google it all the time, things like that. But try to remember that there are some use cases like message order, like duplicate detection, and active, passive, things like that, that you need to be aware of, and you need to take them into account in the moment when you are designing a solution. This doesn't mean that you need to use all the time all of them. No. In the initial phase of the project, when you're doing the design, ask the business stakeholder, how important is reliability? How important is throughput? How important if it's a message is processed multiple times? And based on that, create a matrix, or what are the features that you're looking for, which one are out of the shelf supported by different services, and which one you need to implement by yourself. And be very careful, for example, like message order. Most of the message-based solutions that are now on the market are supporting them. Even so, there are some narrow cases where you need to handle it by yourself. You need to see the narrow cases is applicable for me. Do I need to take it into account? Yes, no, maybe. Depend on your business and technical and operational needs. And you decide if you want to handle that, or the current solution, it is more than enough. Thank you for listening to me. This was all. This is the perfect time for Q&A. Even so, if you want to have a chat with me or to get my input related to anything that is cloud related or software architecture and enterprise architect, don't be shy. Just drop me a line on Twitter or LinkedIn, and in general, in a few hours, I will come back to you and we can schedule a call or just have a chat. So thank you for your time, and I hope that next time we'll meet in person.
Can you hear can you hear me also? Okay, good. Okay. Well, welcome to first of all to this great event. I feel to be I hope to be there physically today to share the networking and all the session and all the content with the attendees and the other presenter. But that's it. Unfortunately, also for this time, I cannot attend in presence, but for sure, I hope to be there for the next edition and the next events that will happen in Sofia. So let's start from the beginning. What we will talk about today and who I am. So let's start. Sorry, doesn't change the screen. Okay, it's this is my more or less description bio, but that's not so important. Remember that you can contact me whenever you want. This is my ID on Twitter, and I can you can contact me there or on LinkedIn, wherever. Obviously, we want to thanks our sponsor that permit to organize this event, and it's very important to recognize that. And so let's start. As you can see, Azure Percept is something that is in preview. The announcement come exactly in the date you see below in March 2021 during the Ignite event, where Microsoft presented this product that is a big a product that is either something that is hardware, software, and services. Let's start from the beginning just to understand everything. If you think about at the AI, or I think that you heard today, you heard the word AI or machine learning, artificial intelligence, whatsoever you hear, that worth a lot of time. And I don't want to repeat again what is the meaning of that. But that's a point that is very important. The AI is something that is actually pushing the service that supporting the AI out of the data center, because usually, as you know, probably you need some good power hours in your hardware to leverage and running AI or machine learning. But what is essentially leveraging the use, the high use of AI during around the world is that we understand that we could fit for specific solution, for specific use cases, we can fit and delimitate. It's not a good word, but explain a bit good what I mean. The scenario that we want to work on. Just to take an example, if you want to analyze, for example, video that are coming from wherever, from a retail shop, from a street in the city, from a train station, from an airport, I don't know, but you have some camera that is getting video and is actually usually transmitting this video somewhere in a data center where this video has been analyzed just to understand what is happening on that video. In the earlier time, for example, that was a task that has made from people, from person that stay in big control center room with a lot of monitors that coming a lot of video streaming, and all of this video streaming are checked by people that check if someone somewhere or something is happening on all that camera, on all that video. The AI permit to analyze, and usually, as I said, we do it with in data center on over some big or power computer. But what we understand in the last year that if we can leverage some specific use case, for example, I want only to analyze, to recognize, for example, people, person, and for example, counting the person that is passing through, I don't know, across a road, or if some person is wearing the mask, that is something usual in this period of time, or if I want to count the cars that is traveling through a road cross. That's something that for scenarios like smart cities is very common. So, but if I can leverage some of this specific scenario, I can also get this AI and put it not in the data center or in generally in the cloud where I have a lot of compute power, but I can try to do it directly on the edge. The edge is a word that means something on the border, something out of a specific common place. But in this case, to specify the edge as a whole is something that describe a way to deploy computer appliance or compute power in general where you normally don't put. In the example I get, for example, I can put my edge device, a device on the edge, if I put it on across the street, exactly where I get the video of the cars that are crossing the street, for example. And obviously, it's something that is high changing in the market and also in all the ecosystem, because if you think about that, usually when we continuing with this example, if we continue, we want to get the video streaming on the corner of the street, and we wanted to through get it and put it through the internet, usually to the network, and transmit to a data center, to the cloud. We need to have a very well equipped network, a good connection with a very low latency, or at least with a latency that could follow the video streaming we are doing. And just to build that, to obtain that on every street crossing in our city, we have to get some high cost. For this, specifically for these two most reasons, but also for the reason of maintaining a situation of security and compliance with specific, for example, country rules, is better not to get the video of a person that is traveling through the street and transmitting that, I don't know where, outside of the city, or in some cases outside of the country. It's better to maintain this video locally, exactly on the cross of the street. Just get the information we need there and transmit only that information, in case in the cloud, just getting the part that don't conflict, for example, with the compliance rules. I'm referring, for example, with the GDPR rules here in Europe. If you know something about that, this group of rules that the GDPR are listing describe a very specific scenario where you cannot use, get, or transmit images or video of a person without their permit, or some country, the internal of its country. And for this reason, we can build the devices and solutions that are very much more economic. We can afford very better with the cost, and we can also for sure afford with the rules, the loyalty rules. So, considering that, Microsoft, what is doing essentially is has considered evolving the adoption of the edge in more or less three great division that named Horizon 1, Horizon 2, and Horizon 3. Essentially, what does it mean? Horizon 1 is what is happening today, where Microsoft and all its partner is actually working on a solution that specifically go to solve a specific scenario and use case with AI on the edge. And we leverage essentially specific devices, specific solution, and very, very vertical market. In the Horizon 2, we are going to get all these specific solution and group them as solution divided by industry. Essentially, you can see on these icon, for example, the stadium arena, the energy, or the retail, or the industry. You can essentially with your in the Horizon 2, we will have the opportunity to apply the solution we are actually developing for big use cases that will cover not only the specific application, but also a whole solution for example, for the retail. And for the retail, we don't think about only to understand if the people will stay in line at the cash just to pay and check out to the store for 1 minute, 2 minutes, 3 minutes, or whatsoever. But also we can leverage a solution like having the stock automatically detected by video analytics, or other solution that could restock the warehouse automatically. All these kind of things. The third part, the Horizon 3, will leverage all these environment together just to build and interconnect, also exchanging and managing together different data. Okay, let's go forward. Where we are here, we are essentially here. These are some numbers that is actually explaining what are the opportunities for going in this market, and is why it probably makes sense for a company, for startups, or whatever, to look at it, to look at this market, because is something that where I can for sure say you that there will be a lot of money in the coming years for the business. That's coming to Azure Percept. What Azure Percept it is. Essentially is, as I said, is a group, a solution that that is a device, some software, some edge software, some cloud software, and some service. All of these is leveraged and working just to obtain a solution that could work either connected or disconnected, and offer out of the box a solution that permit you to use immediately use cases like the one I described, but also you can have some personalization on these use cases. For example, making the AI more precise, or just better understanding what are your industry and your items, for example, that you are producing, or what you are trying to recognize. And you can do it without having to write only no program programming line. You don't have to write any program for that, but you can do everything from the device and from the Azure portal. Let's see how it works and what is it. As you can see, the device, essentially the device kit, is composed by three parts. The main part is the CPU. Is essentially an industrial PC board based on a silicon that is running on a CPU, an ARM CPU built from NXP. The hardware is built from ASUS. The second part is the video percept part, where I have one or two video camera, and also I have where I have these small power heater, power dissipator, sorry, not heater. Below that, I have a CPU just dedicated to AI and network analytics, neural network. Sorry. The third module is the Azure Percept Audio, that is an array of microphone that permit to, as for the video, to apply machine learning algorithm to the audio that is coming in these microphones, and permit, for example, to create solution that could have answer and ask and response to the customer, for example, or just to understand noise or what is happening in the audio or inside a room or wherever you put the device. These devices obviously go together because the CPU part also leverage the part of managing all the module that will be delivered inside the video or the audio device, and also manage the traffic between the edge installation and the cloud. That, as I said, could be a connection that could stay 24 hours a day, or the device could also still continue to work without connection to the network, because it's completely autonomous to work by itself. Okay, here I will leave the slide to you, and here you can find all the exact service and software piece that you find installed or connected to the device, but is something that is not, I think, that interesting, because I want to show to you how it works. So let me go to the to Azure portal. Okay, I think you are seeing this. That is essentially the Azure portal as usual, but I have accessed a specific service that obviously is part of the solution for Azure Percept, and that is Azure Percept Studio. Here, as you can see on the left side, I have some blade, and in the device blade, I have the list of all the percept devices that I have deployed around the world. As you can see, I have connected two Percept devices to my Percept Studio. You can consider that as an hub where I can control all my devices, because behind the scenes is connected with an IoT hub, as usual. Here I can see Pine Percept 1 and Pine Percept 2, that are my two devices, and in this moment I can see that one of that is connected and the other is not connected. What does it mean, disconnected? Not exactly that is powered off. Actually, I can assure you that is powered off because I disconnected it, but usually you can find also this disconnected message because the device is essentially not connected via the network, but in this case could continue to work legitimately in his installation on the edge, also without connection. The other one, the connected one, is here, just here, and I want to show you this one. You see this web stream video. If I put my hands, I feel that you see that my hands is going inside and outside the video. That's the main solution, just to showcase what's happening for the video recognition, object recognition on Azure Percept. Consider that actually the device is, my device is exactly in the way is coming from Microsoft when you buy it. I don't add any new information, new learning to this specific device. So if I get some, for example, some pictures I printed, I get from internet and I have printed, and if I show, for example, this image of a bird and I put in front of the camera, look what is happening. As you can see, the bird is rounded by a block, colored, because if you see here, I have a green colored rectangle, okay, around the bird, and I read the right bird, the word bird, that is the object that is actually recognized, and a number. That number, what does it mean? Is the confidence on how the AI is thinking that the object that is looking at is a bird. So in this case, it says I'm 96% sure that is a bird. That is pretty good. For example, get this one is an airplane. So in this case, is probably a bit okay, a bit more difficult to recognize, but at least it became something that I recognize. As you can see, airplane 099, so it's almost sure that is an airplane. Let's see for a cat. Let's see if where is, okay, here it is. So the cat is not so something that you want to recognize. What I understand in some of my tests, yes, now is a good pizza. Okay, it's not sure if it's a pizza or a cat. Okay, that's it. As you can see, because I don't previously learn to the device that specific kind of cat, and probably the photo is not so good. It's a bit I don't know, not well balanced. And I'm also, if you see here, I also have some light that is over exposing on the camera. Probably is not the perfect way to get, but I want just to leverage that it still work pretty well also in not well connection. That in my opinion is something that is very, very good. Let's So a very old car, Italian car, and yes, it more or less recognize it. It's a car, and it's almost sure on that. Okay, I have other picture, but just to understand what is okay, a cup, and it's a cup. Just to understand how it works, I don't want to go so much in deep, but just to understand how easy it is to use it. And just also want to go forward. I want to return here in Azure Percept Studio, and I open my device, the Percept one, that is the one where I'm working on. From here, from this screen, let me zoom it a bit. I have some opportunity to have some general information. Okay, here I see who is the manufacturer, what is the who has operating system version, the platform whatsoever. As you can see and read very well, it is something based on Linux. Here on the device, we have a Linux distribution built inside by Microsoft. The name is Mariner. Remember this name, this Mariner, this Linux distribution, Mariner, because if you follow the IoT and Edge, essentially, solution from Microsoft, you can hear this one many times in the future. But that's only, and just to say, it's something that Microsoft built internally from ground up. But from here, I can also access, for example, the Vision application, the Vision submenu, okay, where I can do some operation. If I, in some case, have some update for the because Microsoft provide for this Vision, his Vision module, some updates. These are placed here, and I see a button where I have the opportunity to click and deploy the update to my device. And the device, whenever will be connected, because if obviously if it's not connected, cannot be updated. But whenever will come online, he started to receive automatically the deployment of the new update. And that is respect not only of the vision or speech module, but also for all the deployment on the Percept device. That is leverage on also the operating system, all the modules, the drivers, the container management, and whatsoever. Okay, but what I can also do from here? From here, I can also do some other things, like, for example, view your device stream is exactly what you already see, is the stream device that is coming at runtime from the video streaming. The other opportunity are very interesting. For example, this first one, the capture image for a project, is something that permit me to personalize my solution, in this case, the solution I have on the device is the object recognition, I can train my device just to recognize different objects, different things in general, just doing what? If I go here and say capture image, I define a new project. For that, I define the video streaming if it's coming from the camera or from an I can grab a lot of images. All these images are saved in my sandbox. When I completed the acquisition of the images, I can review one by one these images and delimit the object I have get in each image and describe it and says is a water bottle, a telephone, whatsoever. So describe the object. Or, for example, in the case of object detection, if I have, for example, the problem to detect if in my production I am producing good items or bad items, because in the process of building my product, sometimes some items are built in the wrong way, and I can, for example, get some image of good item and bad items and describe that what are the good item and the bad items. At the end of this process, I pressing a button from the interface, the system generate a new recognizing a new algorithm for the vision AI that I can deploy to my system. I can obviously personalize and have change that. I can also modify or update it with algorithm, writing algorithm, for example, in Python, whatsoever, because I am a programmer or I have a team that could do it. But if I don't have a team that can develop that kind of solution, I can also personalize my device vision solution just in this way. And also, I can also, when I generate my image, my perception vision image, I can deploy to all my devices, or also export and give it to other that have the same sort of device. This deploy custom vision project is where I can essentially deploy the new project, or I can also do another thing. I can also select a different environment of application. Here in this tab, what I can do, I can change the general AI that is running on the device. Obviously, in this moment, we have the general object detection loaded, and we can recognize generic object. As you can see from the picture, they are very different and generic. But what I have already on the portal and I can use is already a solution, for example, for people detection. The people detection solution permit me to essentially recognize people, count people that is passing through, see if that people, for example, is wearing a mask, or defining an area, I can understand if this person, someone is passing through this area, or how many times is remaining inside this area. Because if I want to count the time that a person stay in a queue, it's essentially that. Or, for example, I can select the product on the shelf. Product on the shelf is exactly what I said before. If I have, for example, bananas, pickles, oranges, apples in the shelf, on the shelf, I can detect when I have or not on that shelf some specific item. And the fourth solution is the vehicle detection. This vehicle detection can detect automatically if I'm looking at a car, a truck, if I have to recognize the plate of this vehicle, it automatically detect it and send it. But I said it detect and send me, but why? And so essentially how? If you return to the general tab, let me see if I'm okay with the time. Yes. I have a tab here where I can open the View Live Telemetry. Look at it. Actually, I can see that is running a communication between the device and the Azure portal. As you can see in this moment, these are essentially the some JSON messages, okay, where I have some information. And this information is exactly the only information that is traveling from the device to the cloud. For example, if I get the cup that I already showed to you before, and I put it on the camera, look at it. You can read label cup confidence, and you read the number of the confidence that is associating to the recognition, and the timestamp, because it continue to run and continue to recognize what's happening behind the below, so on the camera, and continue to transmit me the information. For example, here I have a bicycle. Okay, if I put it in front, I probably start to see. I don't say that also in the image. I see also the point where the edge of the rectangle that describe the object. Okay, so I can get that if I want and I need. I can also extract that specific part because it's well described. So that's the point, because is how the system is really working. Because in this way, I can apply to this message that I'm receiving to the cloud, to my IoT hub, and getting that, I can start to store this information, for example, and getting analytics on that, or just getting specific information because I need that specific information. For example, when I said for the car plate, it's a good information because I need, for example, to understand that that car is passing on that place, and is something very important. Okay, so just to complete the showcase of what's happening on the Azure portal, here I am on the my IoT hub that is connected and that is managing essentially my Percept devices. And as you can see, I see in the IoT Edge blade, I have the list of my devices. And from here, I also can manage what's happen on that, and I can also do something that is more deeper than the Percept Studio things. For example, from here, I can see the list of the module that is actually running on the hardware. I can, for example, stop one of that. I can update one of that if I have a personalized version of it, because if I say personalized, that means that I get the project on GitHub. That is obviously, as usual, available for free on GitHub. I can personalize some specific module and deploy my personalized version on the system. I can also manage from here the over-the-air updates of all my devices. Let me return to the slide if the system assists me. That is, come on. I'm also doing something very risky because today I'm using my just installed Windows 11 PC, so something could happen. So what I only want to say to you now is Azure Percept is a developer kit. Is something that, to be clear, I cannot place directly outside at the sun at in the outside environment, because if you see here, the board is open. So it's something that is useful for showcase, for developing reason. But what will happen also for the Percept? Oh, just a thing. You see that that's a price. This price is to buy the device from the Microsoft Store. Is already available now. For Europe, is available only for some market, but just in the future will be available also on all the market. I want to go a bit faster. Percept Studio, we talk about it. Just to arrive here. Okay. In this page, I have placed some of the solutions that I have described before, just to understand how they are essentially working. For example, the first one, this one is for the retail opportunity, and I can in this way understand how much time the person stay in the queue. On the second one, I can easily see what are the stalls free for in the parking and the stalls occupied. And also when a new car arrive and park, all the new stalls are updated from free to occupied. Okay. This one is for a solution for security. Essentially, I don't want, or I want to be advised if someone enter in a specific delimited part that is inside the screen, because it's something that is not usually understand or happen. The final one is more complicated. I want to describe it. If you see, there are 3 workers that are around this machine, and just only one of these person is surrounded by a red rectangle. And at some time, this light is turning on. Why is turning on? Because in general, this is the area of working of a big machine, and these three people are working on this machine. But what is intended by the red rectangle is that in that area is not permitted to stay for any person. And what's happening actually now is that the system is recognizing that a person, a worker, is inside the area that is not actually permitted. And what's happened? That is we leverage the light with the alarm and start the alarm just to advise that you have to go out of that zone of work. These are just example, very simple example of how to use it, but I think it's only by your imagination. Okay, so let me go to the end. Okay, essentially, this device is built with the security in mind, and essentially the thing that usually we can do with the remote devices, edge devices, IoT devices, like to use that to attack our network is something that very difficult could happen, because we built these devices with the all main industry security feature that are available today. So, what I can say now, not much more than, okay, this one. Actually, as I said, the device is available on the store to be acquired. But you can see that are some distributor that will distribute that around the world in all the other market very soon. Here, instead, you can see a lot of our partners that are already working to build their own Azure Percept devices for specific industry. I showcase that we can apply for different industries, different application. All these partners are actually building different devices with their own CPU, their own hardware, their own solution, and leveraging specific scenario for the market or specific industries, just to go very deep to the solution of the Horizon 1 that I said at the beginning of the session. So in the near future, you will appear on the market a solution that will be based on Azure Percept, built by different of these partners that will obviously run on different hardware also, because you can see also Sharp, NEC, Intel, whoever that is not something similar to the hardware I'm actually using. Okay, I feel that that's all. You can access the resources for Azure Percept from the link that I leave on the slides. And what I can also add, if you want to have some more detail, you want to talk about these or also on other solution about IoT, Edge, and AI, I'm obviously available. I'm also, I don't know if there's time now for some question and answer during the event, but if you want, you can contact me later, as I said before. So thank you very much, and see you hopefully in physical way and not online at the next event. Thank you. Bye.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, IoT, IoT. IoT, I check my stock. What a shock. Buy some prawns. My oven's on. Coming home. Future zone. All for me. IoT. 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 Live like a Bosch. With many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и
Do you know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1024 BGM,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
Hold up. I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heating smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition
Don't know how to become a technical lead? Well, we have the answer for you. It's MentorMate Technical Lead Accelerator. It's a one-month training program for senior developers of any technology, which will help you build your leadership skills, give you access to a variety of trainings,
as well as a personal budget of 1024 BGN,
and a personal mentor that will help you along the way. Sounds intriguing? Then apply from the link below.
Hold up. I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. Connected, so effective. Let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one. These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department swing to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
Start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car, superstar. They're watching me. IoT, IoT, IoT. IoT, I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT. 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 Live like a Bosch. With many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Okay, hello everyone. Can you hear me? George? Okay, perfect. Okay, welcome everyone. Thanks for being here after your long day, with all session. So this is the last session. Thanks for being here. Just a note on myself. My name is Marco Parenzan. I am a developer, a consultant in Italy. I live in Pordenone, that is a small city in the northeast of Italy. I put when I speak in international meetings like this one, I put the geography so you see that where is Milan, where is Venice, and Pordenone is near Venice. If you don't know where is Pordenone, and there I have also my community where we do events like this great event to share content with you. I'm an Azure MVP, and you see some links if you want to reach me after this meeting. Thanks obviously to the sponsor, to the organizer for their engagement, for their help, because I personally, as I organize myself these events, these kind of events, I know how much sponsors are important. So thanks to everyone, and thanks to the organizer. So in terms of session, AI and IoT IoT event, I like to speak about time series anomaly detection with Azure and .NET. Why I speak why before about this session? Because as on my work, on my daily job, I work on several different projects, but also I work with IoT. I have my experience, that is the experience from many people, but also people that has not the same experience. We cannot approach IoT solution like a legacy developer. That means pure code, pure imperative code, and relational data. I still find in customers, in people I talk to, working only with relational data. I can say that working only with imperative code and relational data is no more cost effective to have modern software in general and IoT specifically solution. One constraint that is my personal constraint, but I think that it can be a constraint that is shared among a lot of people if they that has like me a background as a .NET developer, try not exiting from the .NET comfort zone. What does it mean? That besides I live, I let myself use some kind of new tools or languages, for example, more on the data platform, but I'm less able to use other tools or languages. For example, if I say, as we will talk about Python, for example. So for me, .NET is a constraint, and this is why the title is Azure and .NET. So just an agenda. Let's introduce a scenario and then some topics that I want to speak about. So let's start with the scenario. A classical IoT scenario, a classical for IoT because we talk about temperatures. Yes, you know, when you make experimentation in IoT and you think about Arduino or Raspberry Pi, you think about the temperature sensor. And you say, oh no, a session about the temperature. But just to say that temperature is quite important as a measure, as a sensor and a measure to be done in a real world scenario. Not just for environment, yes, this is smart city scenario. But for example, when you think about industrial fridges, so you speak about supermarkets, big restaurants, or butcheries, where you have big fridges that contains a lot of meat, a lot of meal, where having a freezing cycle that works, it is quite important, because if the cell is no more refrigerated, you lose a lot of money. So, so measuring the temperature is not about only or mainly the environment temperature. Yes, you have as you have all the temperature, you measure also the cell temperature. But what is more important is the temperature about the condenser and the evaporator of the freezer itself, because there are many different temperatures because of heat exchange that are important to measure to understand if the fridge is working correctly or not. So, but in general, as you speak about industrial fridges, you have no specific request. What do I mean about that? I mean that currently you can receive a specific request. You can, because there are some customer that ask specifically for that particular need, but also you have a customer that hear about speaking about IoT, but because they have to approach, why do I need to approach? And the answer is mainly because you have to trace or efficiency or anomalies. So this is the main measure that you do. Efficiency, that means I performing well, for example, in freezing, or there are anomalies that is too cold, too hot, not too much cold, so the condenser and the evaporator are not working well. Uh, about streaming and batch that are scenarios that you know about IoT, which is the scenario for fridges. Fridges is a slow scenario. That means that when you have difficulties or some breaks on a fridges, you have no immediate reaction. Why? Because you have an elapse of hours, at least, because if the fridge the more it is big, or just open and close the door, you have to say that the refrigerator, that the cell maintains the cooling. So it is not a real-time streaming scenario. A batching scenario is quite enough, mainly for refrigerators. But obviously, we can also discuss about that. But in this session, we will talk about mainly about the batch scenario. That is a good approach to start with IoT in this scenario. So, from the batch point of view, this is the current situation. You have the devices, you have sensor temperature on the fridges, you have some collector of measurements of events, for example, an Azure IoT Hub, for example, and the typical action that is done with receiving the event is just storing the event into a storage account, just writing the measure inside, appending to a file in a storage account, and that's it. Why? Because when you start with a new plant, you have a system that is functioning. So you start, and then we will implement the IoT scenario. This is typically a discussion with customer. So we have, in general, we have a great history of data to which we can work on in a plant, because the system is collecting data since a long time, never had a reaction. Now it's time to make this reaction. And the reaction have to be done on two main concepts. First, the thing that the events that are collected from the IoT scenario is a time series. Time series, that means that all the data are collected, ordered in time. Time is important because there is an order on the events, and because of the sequence, we can make some hypotheses on that data. For example, the data are correlated one another because of a sequence, or we can have seasonality, for example, because some events repeat. Things, for example, that if you have a restaurant, the fridge open, for example, always in the afternoon, for example, because they have to prepare the evening, while on the morning the fridge is closed. Or and this is a seasonality on a daily basis, while the fridges works more on the weekend because more people go to the restaurant, for example. And on the summer, it works more because it is much hotter in the environment. So in this way, we have seasonality. This is important because algorithms on time series suppose this kind of events and structure of events that you collect. Anomaly detection in time series is finding anomalies, or what we call outlier. That means value that are far from the average, too much far from the average. This is an outlier. This is anomaly detection. So finding these anomalies is the objective of this activity. And the assumption is that this kind of event occur very rarely. So if they become more frequently, this can be a real anomaly. If you have one glitches, for example, in a long time series, probably this could be not an error. Okay, so why do we need some tools to support? Because mainly, if you speak about traditional implementers, the only tool that we have is that notion of threshold. That means if the instant value of what you receive from the sensor is higher or lower, depends if you are looking for hot or for cold, over or under a threshold value, this can be an error. This is not correct because the threshold is not enough because the sparks, so the casual events can appear more frequently, but they cannot be a real glitch, a real outlier. So we have to look to the entire signal, so to the entire list of events to understand, or better, to look inside a number of events altogether to understand if this is an error or not just one single value. So in this case, we need some tools and probably help from someone else. And if you think, for example, about artificial intelligence and machine learning, helping from a data scientist to do these things. So how we can implement this process, the process of detecting anomalies with Azure and .NET, and this is the topic, if we don't just want threshold over a single event, that is the only thing that we can do by hands as a simple developers. We have many different options. There are in a variety space, there are many different options. If we look about Azure, we have some specific tools that we can do, specifically using services exactly from Microsoft and Azure, because obviously we have also solutions that are purely open source that can be hosted by Azure, but in this case we want to focus more on a specific Microsoft offering. So first and foremost, if I have to say a service that is good for that is best, more than good, best for time series data to detect anomalies in time series in IoT data, is Azure Data Explorer. What is Azure Data Explorer? Is many things. Is many things that are many different aspects of time series analysis. It is a telemetry data search engine. That means if you think about our tools, our tool Elasticsearch, for example. So ADX can supply what Elasticsearch can do for you. Then it is also a time series database, a database that store exactly data that are time series, not relational data, not column data, but time series. That means, for example, having a solution that is built with MinIO and Kafka. It is a tool to materialize data into Azure Data Lake storage and SQL. So before storing data inside SQL or Data Lake, you can manipulate data where? In ADX, so in Azure Data Explorer. And also it is also a tool for monitoring, summarizing, and send notification. What this means that ADX, that Azure Data Explorer, is a feature complete platform for time series analysis. Obviously, as every service that is, we can say, if there's a lot of features, you use what you really need. You can build it completely or part. We will look just some few capacity of the Azure Data Explorer, and obviously I invite you to understand after this session what ADX can do completely for you. So when you speak about IoT data, obviously you can manage the three classic tiers of data: hot, warm, and cold. That means how fast do you want the reaction with the data that is ingested. Hot, that means streaming, so that means that makes it almost real time. Warm means seconds. Cold means batches. That means what we need uh, currently in this moment. So ADX is the step that stay between the raw data that are collected from the ingestion in the IoT solution and your data warehouse. And so it can cover the role of the need, it can cover the needs of the IoT developer that has to check the data from the ingestion to understand if something is wrong with the sensors, the data engineer to understand if how the data is going, comparing to the time series that currently go over time, and data scientists to understand if there are specific issues with the current data. So how IDX is organized? What I like to observe in what is ADX. First and foremost, ADX is a cluster of machine. You have a cluster of virtual machine that is managed by ADX itself that gives the computation. Is more like a Kubernetes or a Spark engine. If you want to compare what is ADX, is a cluster like that, so more like you can say Spark, but it is different from Spark. What I like to say is that it has a storage of its own for data, but it has the notion of sources that has external sources and external destinations that are by which ADX interact with. What I mean with that? The fact that ADX, like all the modern big data platform, has a control of data on the platform itself. It means creating their own database. But also, it is important to be able to manipulate data sources from the external. What there is external? From other services, for example, what is important is manipulating JSON files, CSV file, Parquet file. The file is important in big data and in IoT. And this platform, like other platforms, are great to manage this kind of thing. What does this mean? This means that, for example, files are no more a function of an application. You don't open the CSV file like you manage parsing in your application, but you have a platform that can manage the data more performing in a more performing way for you. So ingestion of different file formats is one of the main feature of ADX. So it can parse AFRO, CSV, JSON file, Parquet, semicolon separated values, tab separated values, and think that for example, in ADX, this is important. While other platforms think that CSV is a generic file format for separated the value in rows, okay, so CSV is like CSV and TSV, like Excel, just to say an example. In ADX, CSV, CSV, TSV are different file formats. You cannot specify separator, but they have their own management and different management. Also, what is important is that because the ingestion can be quite big, it has to scale a lot. This file can be automatically compressed because you receive this file compression, so you can receive a file that is compressed, so it can be automatically decompressed before the processing. This is done automatically from the platform. What is different in ADX from our platform is that as our platform choose to try mapping skill of people from SQL. That means as you are able to make a select query in SQL, you are able to make a select in a platform. Things, for example, in for Cosmos DB, if you think of Microsoft in Azure platform, in ADX there is another language. Yes, there is a select, but it's just a select. Forget it. So in Azure Data Explorer, there is a new language that is custom. If I if I say correctly, sorry, in English. But is you see on the bottom left of the cover, you see that if you think that this is a select, this is the same select in Castle language. It is more like a C# link queue expression more than SQL, if you have to say, because think that Storm instead of pipe you have dot. It is more like that. And this is what is really this a more functional way to express the query. And I have to say that with my skill as a developer, this syntax is quite more comfortable, because as I am a C# developer, I find it far more comfortable. Just to look at to see some examples of query, I have put that only for example, because I prefer to show you directly. And so we go on the first demo. So as you see here, this is Azure, and this is the Azure portal, and here you have my personal cluster, my personal Data Explorer cluster. As I tell, it is a cluster, so it is a management of machine. You look here, compute specific. I have currently a developer test cluster, and you see that the minimum for a developer is a couple of virtual CPU with 14 gigabytes memory, 80 gigabytes CPU, and it costs because you see that are $19 per hour. But if you think you can have, and I have currently one machine. Why? If you scale up, you can have this kind of machine. These are the tier that you can use, but you have at least 3 machine deployed. Yes, ADX it is not really cheap, but is a lot of power. And as a lot of our Azure services, ADX is great performance, but it is in his early years, because it is about 3 years that ADX is alive, and we have to say that there is a lot of adoption, and currently we are waiting for the new tiers of pricing that can drop the pricing and have a massive adoption of this tool. But okay, this is a topic that I don't want to speak about the cost. I know that the cost is important, but let's concentrate on the content. You see that you have here a query and you have databases. So you have your cluster, and on your cluster you create a database. When you want to perform a query, you can do it inside the portal, but also you have your specific platform for that. For that, you have dataexplorer.azure.com, and here you have a single survey, a single page where you have access to all the cluster that you have in Manager. So here you see that I have, this is my cluster, and under there is my databases inside that cluster. And here obviously I have only one cluster. Here you have another cluster that is shared among all the users of ADX that contains some sample data and sample database that you can use for your experimentation. So let's look at how working with Azure Data Explorer means you see that I have my KQL file, and here I show you that there is a create table IoT events. You see that I have my IoT events, and you see that I have a schema in which I create installation name, field name, time, field value, measurement. Okay, this is the table. How do I insert data inside this table? Do I have an insert instruction? No. I have a mapping. You see that I have create table ingestion mapping. You can query for that on your cluster. Okay, you see under. You see that okay, this is the mapping, and here I have a creation, and you see that I am creating a mapping between the table and the CSV. I call it this way. That means that I can have multiple mapping on the same table from more CSV, but that has different structure. And then you have columns to see that you map the property of a table with the ordinal column inside the CSV. And you can make more mappings over the same table because you have different file formats, you have different sources that you can load data inside. How do I load this data inside it? In this particular way, I have an Azure storage. I have an Azure storage. Here is an Azure storage. It is a data lake specifically, but it's not important for that. And you see that what I can do is upload file. For example, this is a simulation, obviously, from your point of view, about what can happen in IoT. That means load the data because IoT, store the data because of ingestion. If I go here and I say I look for data and I load, for example, July data. Okay, I upload that data. What can I check? Okay, if I make this, okay, you see that this is a query. This is a query from Custo, and you see that let's check this just to make a sample. Okay, I look. I have told that I have loaded July. Let's look if July is loaded. Okay, so I put July the 1st, August the 1st, and show I run. Okay, no rows. Why? Because I am in a shared cluster, because I have my developer capacity, it makes sometimes to load. So we put this query here, and one time I will find this. How does this work? It works the fact that behind on this storage there is connected an event grid that intercepts events with on the storage, and then when the file storage is created, the file storage is created, a trigger launches this file on an event hub that loads data inside the ADX cluster. Okay, let's look after. What can I do? Okay, if I go, for example, from January to April excluded, that means March, but okay, I have only data. Okay, you see that I have already data inside my cluster. You see I have a query from February. Okay, that's great. Let's go to this page. If I look at this code, you see that we have start time and time. Okay, you see that I have where time between start time and time, filtering. Okay, then you have summarize, make list, and then you have series decompose anomalies. You have functions that are already implemented in Custo inside Data Explorer that detects anomaly. Let's look what happens. Okay, I execute this. It runs. Okay, and you look at that. I have my graph that is the time series, and you see the point. There is a threshold that says that which is the tolerance over which you have this anomaly. If I lower this, I make my experiment to understand if there are more anomalies, I can work with these parameters. I can run again, and you see that in this case, I detect more and more errors. It depends on the parameters. This is the work mainly for the data scientist, the data engineering, finding the correct tuning of the dots. Okay, I have discovered that dots that are errors. Okay, let's go. And these are okay. Okay, what can I do? You see that the same code I have changed a little bit because I have used another function that is the more basic about that is the outliers. Okay, you see that I have included this code inside a function. Okay, you have a function, we can create a function, and you see that I have the parameters, you have the data. If I run, I have my data. And if I include run, you see that I have the same result as before. The difference is that I have separated, okay, not exactly the same. Oh yes, because I have this is different because there is a line chart. Okay, so it's okay. I have the two. You see that this is the outlier and this is the serial without the errors. So you see this is the value and these are the spikes, and this is the series normalized without the spikes. It performs another task, but is almost the same. Okay, I have discovered all my points. Okay, what can I do? I can make export, for example. For example, you see that I have the same function, and in this way I generate a file. I export to another CSV. It can be another thing, but for example, the most simple thing is using CSV. So we can trigger and move on the data. Because one of the main topics of ADX is the refinement. That means process the data so you can collect your data and making something different. So if I look here and I go to the export, you see that there is nothing. If I go again to the cluster and I click run, I run an operation. This is manually, but I can schedule this thing entirely in ADX, and I can find automatically that file here, and you see that I have my export. And if I open it, it is another CSV. In this case, you open as Excel file. And you see that I have just three value. What are these three values? Okay, you have the time, you have the value, and the outlier. What is different? So you have your process. If how do you use this tool inside a C# code, because you are a .NET developer? You see that you can write a C# code. Here you can have your query as the complete query, or you can have your specific function, and you can execute. You obtain a reader, and you can use the data as you want. I can launch. authentication, that is implicit in this case because I am already connected. Just a second. Okay, haha, an error. Yeah. No, no an error. Okay, and that's it. And you see what I have done. I have covered all the file, but I have written only the files that are only the rows that has outlier that is different from the value. That means I have found what the spikes are. So I have found, for example, 68 events on 4,000, 4,100, 4,200 events. Is this exceptional? Too much? Too few? It's your experience about that. But think that you can tune again the parameters, make some more experimentation to understand if this is a number of events of outlier that require you to notify someone or not. How can you notify this? You can use a logic app. You think that logic app is Logic App has a specific task for Data Explorer. Quite slow, sorry. But I show you the result. If I go to the email that can be launched, I have deleted it, but I show you. You see that you can send an email like this. Sorry for slow. Sorry for. I tried to reopen another one, probably cached. Okay. Sorry, probably I have some. Okay, here you see I have my logic app, and you see that I have okay for currency, run and query visualize result. That you see the icon that is the ADX. In fact, you see that I am connected to the cluster, and I have my query that is exactly the same query that you have seen. And if I go again back to here and I try to look at the mail, okay, it does nothing. Okay, this is classic demo effect. But okay, you see that I have a picture of a plugin generates an image of a graph that you have seen of the designer, and you look it inside the email. It is notified, and so you know that there are some problems with your data, and then you decide how to manage that event. So okay, this is Azure Data Explorer. I have taken a lot of time, so I have to cut some content. Okay, I skip about signups because it no much time, but it's important for me to show ADX because we speak ADX enough, and I skip and I go directly with this. Okay, what I can do if I am a .NET developer. I skip that. Sorry. I skip fast. Okay, how data scientist works? Data scientist works how? Today the standard is Jupyter. Jupyter is the notion of notebook. that is a concept that is born on Mathematica, just written in a web standard way. So with Markdown, HTTP, and Python. Okay, sorry. I continue. As Python has a connection with Java, well, nicely, we have also a connection with .NET. There is the .NET Interactive and Jupyter that allow you to manage notebooks also with C# and not Python, and that's good for you as a .NET developer. So if you want, data scientists work with notebooks, but you need a library to make machine learning. How do you do machine learning in a .NET environment? You have the ML.NET library. That is a complete .NET library, native .NET library, with some bridges, yes, on pure C DLS, that is the same also for Python, and to make all the tasks that you need. For example, the anomaly detection. Anomaly detection is a standard tool, is a standard function for ML.NET. So what is interesting with anomaly detection is that besides the classic process in the anomaly in machine learning, that is training, test, and predictor. Training test, that is the training phase. That means that you have to prepare your model and then you test. Anomaly detection is something that has, because you speak with people that has no time to train this, there's a lot of interesting algorithms. For example, spectral residual CNN, that is convolutional network, that is an algorithm written by Microsoft itself, that is interesting because it is a model to detect anomalies in time series without training. Or better, it uses your same data to auto-train the model. So for you as a user of this kind of algorithm, you don't need training. You don't need to train by you because the model trained from itself. And this is important because, as I told you, training or having more supervised learning, that means tagging also, is an important part of the data scientist work. In this case, we are safe from this practice. So we need .NET 5, we need ML.NET. Here we have also VPF, but it's a more complete demo in this case. But we have also a plot library that is xplotplotly, and I show you how we can do .NET with notebooks. So for the second demo, I go here. You see that this is Visual Studio Code. This is Visual Studio Code. Visual Studio Code is our editor, not IDE, because we have Visual Studio for that. That is good to do all this thing. Inside the notebook, I can install .NET Interactive. With .NET Interactive, I have this option, F1, Open Notebook. Okay, click on this. And I look inside, I see you have two formats, the DIB, that is the .NET Interactive book, that here the native format, and also the legacy for .NET Interactive, that is the Jupyter notebooks. And you see that you have ML.NET SR CNN. Okay. I open it and I see this. So what I'm doing here, I'm doing the data scientist with my .NET. You see that here we have a notebook is the mixing of the markup called markdown code that renders in HTML and the C# code like scripting. That is almost like scripting. Every cell is an executable. Okay, so I can execute. Okay, and you see, okay, here I have the libraries. This is Nugget, is download the package from Nugget. Okay, I click. Okay, you'll see that I can define classes, and this is code from lml.net. So I load data from the file, from the CSV file. It takes a little bit to start up the kernel. Okay. Okay, here you see and all the file because I have it locally, but in general you think that I load it from a file system from an Azure storage. But okay, this is all the way to parse file. Okay, so I click, I run, and then I'm running this code. Why I see that this code is run? Because if I go here and in a functional way I write data is an expression. Okay, nice. It is empty. Okay. As you say, that was not supposed to happen. I use it all the time, this kind of file. I try to... Okay, because I try to look text. Okay, you see that I'm writing. Okay, sorry. I make a mistake because I have changed the format. Okay, you see that I'm writing text. So I correct the code live because the file is changed because I have the comma as a separator. Okay, so I re-execute this, and if I write again data. Okay, you see that I have this. Okay, here I have an error on the file because I have a change because it is a culture problem. Sorry, because I have changed the specification. So you see I have the comma here. I use the point. So to make the I try replace the dot with the comma. Okay, I'm writing it live. So this is real. This is real. Okay, and you see that I have changed it, and so I have finally the correct file. Okay, load the model. Okay, another class for the prediction. Okay, detect the period, the seasonality. Okay, I have some parameters and the execution of the prediction. And then I have this library that is called Plotly, that is a graph rendering library that renders. Okay, you see that I'm installing a package from NuGet, in this case, in which I render the graph. So just to say that as what data scientists do, that is render and look what happened. And what I have done also in ADX, I can do the same in this notebook. Just the time to download the package, because you look at that there is here the download of the package. Think about every single notebook that you can open inside Visual Studio Code. So it's an independent environment. Okay, you see that the package is loaded, it is installed, and if I go down, okay, you see here that I have a graph. Obviously, it is a different rendering between with the ADX, but the result is almost is almost the same because I have detected the outlier inside the series. Oh, then also this rendering is quite nice because it has some tooltip that can be configured. Okay, so what is the result now? I detect outliers. I draw graph to show you that there is some failures, some problems that you can act. Okay, from what you have seen, I have done in ADX. I tried just. Okay, you see, this was the email, and you see that here you have the enclosed image. Okay, and this is out of the box with ADX. To do the same in .NET, first I have experimented the code inside Notebook. So I have tried to find the correct way to detect outlier, to detect anomalies. Perfect. So the next step, which is the next step? The next step is hosting. The code inside Azure. How do you host this code in Azure? You can use any hosting solution that you have in Azure, but the most typical way to host this code is Azure Function. And then you use Logic App, like we have already done, to notify the who is important to be notified with this information. So what can we do? If I go here in Visual Studio and I go to this function, you show here that you have my handle telemetry that is, okay, blob trigger, that is, I send an email. Sorry, sorry, my fail. I load a file inside the blob storage, I handle it. Okay, I have to change this, and probably what I will probably find that does not work because I have the same problem here. So replace, because I have not thought that I have to change this. Okay, so in this case, we will also see some code that I have already executed, and I take it. Okay, but in this function trigger from a blob, I read the file, but think, for example, that I could to an ADX that can store that data already parsed without that. We can choose any trigger that we want, just to say that this is an independent way to do the same result in a lower scale, obviously. You see that there is the same code I had in the notebook. I have my chart, but instead of rendering, what I do is sending and making an HTTP call to an endpoint, which is that endpoint. If I go here, you see that I have a notify bulk that is the same function as before, and I have that is useful overall, not to make the prediction because we have already done, but with a function have computed the message. This logic app is good to make the mail sending to the person that have to receive this information. So that I have probably some issue of the connection again. But I go to update custom, so the mail sent by ID, but you see that here I have other samples that is sent by the from the function. Okay, but I said I have enclosed. Okay, I have enclosed an HTML file that I download, and if I open file, it is an HTML file a different implementation, but with the same meaning. Okay, and here, okay, here I have quite more points, but it's almost the same. You see that I have my traces, so I have my read, the predicted, and the specific outliers. So again, you can implement as you want. You can notify with all the constraints, with all the checks. But what is important, the message that I want to give, that you have a lot of tools that you can use for this to do the same thing. Okay, so in this case, this is what I can do, for example, with ML.net. Just a couple of things to show before ending. First, I had an example where instead of using ML.net, so I have to make some code. There is a service in Azure that is anomaly detection. You see that in .NET there is a library, Azure AI Anomaly Detector. This is a service. If I go here, I look at this. Let me find. Okay, I find here. If the connection as well. Okay, it is a cognitive service. If you know the cognitive services, that is the pre-trained implementation of artificial intelligence, anomaly detector is one service of the family. So in this case, what I want to say is that to use this, you don't need to write all the code that we have written for ML.NET. You have just to collect the file, and you just make this is what you need to make a call. So you see a request and a request and the call and the response. Stop. That is far more simple rather than ML.NET, and this is good. So because you have not to implement nothing because it has already. It is the same algorithm, the SRCNN, the same algorithm, but in a more manageable way. So you can use this to do a prediction to anomaly detection outside ADX with .NET code. And just to say, because I have no more time to show you, but think that if you are not used with ADX, but you are more big data user, for example, with Synapse, okay, think that, just to say a few words, Synapse has now evolved as a platform like ADX in managing external data, unstructured data, not relational data, for example, CSV, to look at like relational data as external table. And what is important is that with Synapse you have also the Spark compute engine. And what does this mean? This means that you have notebooks inside Synapse. You have okay, this is not the code, sorry, I want to show you, okay, anomaly detector. Okay, this is the Python version of the code for anomaly detector, but sorry, I have, okay, this is the code. You see the same code that I have used to make the prediction here. If connection works well, it is, you see that I'm inside Synapse, I'm writing .NET code, and at the end, if rendering goes well, you should see that there is also the ML code that I can execute inside Synapse. And to say that Synapse has the new Azure SQL Data Warehouse has become a platform to make computation on big data, more generic big data, and you can have Spark compute that can allow you to use, for example, .NET the same way I have written in this notebook. It is the same notebook. Sorry, because vision is quite slow this day, and it is not finishing. It is not finishing the rendering. I'm trying to make a refresh. But okay, quite slow. Sorry. Okay, I go. Okay, cognitive services as a service. Okay. So to finish the session, sorry that I haven't taken a lot of time. IoT scenario is all about the data. So you can't think in IoT if you don't think about data. And the data solution require data platform. It is no more the time for the classic legacy developer that does not use data platform or the use of only relational data. I still find customers that work only with relational data. It is no more the time. You have a lot of choices for developers about data, about time series, about columnar data, about big data, unstructured data, JSON data, not still relational data. Relational data are just a little part of the entire scenario. And this is our, and you see, as I am a developer, you see that these scenarios are now more approachable by the developers. And with machine learning, with ML.NET, or with cognitive services, anomaly detector, data platform are not just for data guys, are not just for data scientists. And I hope, because this is something that is quite important for me, because I have my experiments using Python, but I have a lot of difficulties just for concentrate because I have a lot of things to do and I have no time to use Python. It is for me it's quite more simple to understand a new language like Custo rather than thinking on Python because I am already C sharp. This is my constraint in my mind. Okay, so this is my idea. So look at the ADDX if you can, look at .NET if you can, look at notebooks if you can, look at ML.NET, look at also Synapse, that is a good platform if you are more data oriented, database oriented, or data warehouse oriented in your skill. Okay, thank you. To remind upcoming events for the community, you will have Data Saturday in Plovdiv and Sofia in the next months in August and October, and the JS Talk in Bulgaria. And I have also, let me show just to say that Data Saturday, but here in Pordenone we ran the first Data Saturday of the first Data Saturday, because Data Saturday number one was exactly in Pordenone. I have organized it on the February 27th. So just to say, go to the next events, because the guys that have created these events are great and they are spending a lot of time. So register to go to Plovdiv, to Sofia, and to JS Talk, because they are valuable events. And I hope to attend also to the next event. I will, if I could, I'd like to attend. And when I have the possibility, I will share you the Data Saturday Pordenone link for the 2022. Okay, thanks again for the sponsor to organizing this event. So I have finished. So thanks Georgie. Thanks to the organizer for the event. If you have some question, I'm here. As if you need, you can contact me to the reference. I will share the slides so you have all the contacts to contact me if you want. I'm pleased to answer. If you answer, please chat or thank you. Georgie, it is okay? Okay. If there is no question, I thank you everyone to attending this session, and I say goodbye for another event. Bye bye.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stocks. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT. 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 Live like a Bosch. With many connectivity solutions for a smarter future. From Bosch.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.